So by now, absolutely do not be scared of electricity. Just hold the master's hand tightly. Not too tight, my hand will hurt. So bhai, it's possible that you might have studied the topic of electricity with a teacher in school or watched a few videos on YouTube, but still the questions of electricity are not getting solved. The topic is still not being understood. That combination of resistance, that current in the circuit, that power, nothing is getting grasped. Do not worry, after today's lecture, you will not leave as an excellent student of electricity, but an excellent teacher. The master has come to make you an excellent teacher. Do not worry, bhai. Whether it's your school midterm or it's your school pre-board or your school's board exams, by you are in 10, there will be board exams. All the questions inside, all of them are going to come from within this lecture. The master is not just boosting. I am saying this because till now you might have watched few videos, but those were just ordinary one-shot videos. This is not just one-shot video. This is the master's gunshot video. Gunshot means the bullet came and went straight the eye through the chest. 100% NCERT I will cover definitely inside this. Every single topic, just like halwa and the spoon, I'll put it in your mouth. Beautifully I will feed it, you will understand everything. And 100% of the exam paper in the exam will be made from here. Why? Because inside this I will make you practice a lot of questions and more than 40 previous year board questions. What came in 2025? What came in 24? What came in 23? What came in 20? I will make you solve a lot of numericals and everything will be understood. Don't you worry. Should you start by the topic? But before that, we have a tradition. We have to fulfill the tradition by we entered the system. You're part of system. That tradition is that you have to start the lecture with full confidence, not with fear. It's possible you might have some friends who are ahead of you in studies, who are ahead of you in school too. Remember one thing. No matter who is ahead right now, in the end, I will win. At last, I will win. And everyone has to write this in comment section that in the end, I will win. No matter who is ahead right now, what do you have to write in the comment section? In the end, I will win. Let's start by this beautiful lecture. First of all, what do we all have to study by? So inside this, I will teach you electric current. I will teach you potential difference. I will make you understand it. I will teach resistance. I will make you solve questions. We will understand Ohm's law well, series parallel combination. We will solve excellent problems of electric circuit, electric power energy, heating effect of current, Joule's law, all of that which is there, I will teach you. We will practice more than 40 previous year question right here. Should we start by? We have already written in the comment, I will win in the end. Let's start. The very first thing is charge. Remember the symbol of charge. The symbol of charge is Q. What is the symbol? Q. There are two types of charge in the world. Positive charge, negative charge. Everyone knows this. Okay. Like charge is repel. Like means same. If you place two positive charges nearby, then they will repel each other. They will go far away. If you place two negative charge nearby, like charges, they are the same. They will repel. So two positive charge repel, two negative charge also repel. But if you place unlike charges, one positive, one negative, then what will they do? They will attract, just like you are and the Babita is yours. They are unlike, they attract each other. No, sir. The attraction is only from my side. No worries, it will happen with time. Okay, it's very simple thing, you must know it. Next thing, the SI unit of charge is coulomb. The standard international unit of charge is coulomb and the symbol is capital C. So the symbol for charge is Q and the symbol for its unit capital C. Let the fact be fitted in your mind from this page. These scientists were Coulomb. The unit is named after them. You should also discover something in your name. What is your name? Abhishek, Anket, Shubham, Priya, whatever it is. Invent a unit in your name. Let it be written in your name that by Priya's unit is this capital P. In the comment, tell me what will be your unit. Let's move forward. The smallest independent charge. This universe smallest and isolated charge who can live alone, just like you are living alone. It's compulsion, I know, no one likes you, but it's not their compulsion. What is the smallest charge in the world which charges on electron? Electron, chacha, you know, little chacha we have. The charge that is on the electron, it is the smallest charge of the world which can live alone. We call it fundamental charge. Fundamental means an extremely basic charge. That is the smallest charge. Its value is 1 electron is equal to minus, then electron is negative charge, 1.6 multiplied by 10 to the power minus 19 and the unit of charge is coulomb. So capital C. From past 5 years, CBSE has not asked this, but still remember, 1 electron is minus 1.6 into 10 to the power minus 19 and the unit of charge is coulomb. Next topic by is important, current. Current mari ye bijuria. What is current? Current is the rate of flow of charge. Current is rate of flow of, now forget that, rate of flow of charge. In physics, if you put rate on anything, it means divide that thing by time. Rate of flow of charge. If you put rate on that thing, divide that thing by time. We will remember the symbol of current. What is it? Capital I. Little I is also used. The symbol is I. Now we must remember the formula of current. So current I, what is it? Rate of flow of charge. The symbol of charge, Q. And since we put rate, we divide it by time. Okay. Q is our charge. Charge is measured in, do you remember? Coulomb. T is our time. The SI unit of time is seconds. And I is our current. What is the unit of current? It's written here. The SI unit of current is ampere, capital A. Also here it will be measured in ampere. I is equals to Q divided by T. You should memorize it. It looks a little strange. Let's see a simpler form of it. If I keep Q here and T to other side, then it will multiply. So can I write Q is equals to I into T? Q is equals to I into T. This is very easy to remember. Suppose someone came into your life. Say talks happened. Then she went away. When she went away, what do we think? Why did you give so much pain? If you had to leave, why did you come? Only one question remains. तुम क्यों आई थी? क्यों आई थी? क्यों आई थी? Q is equals to IT. क्यों आई थी? Clear? Formula is clear. Now comes the direction of current. In which direction does current flow? Okay. Suppose this is a conductor. Conductor means the wire in your house. The wire is conductor. Okay. Suppose electrons are moving in this direction. It is the electron beta which moves around, goes here and there. Electron uncle are going from here to here. Now look at the definition of current. Current is the rate of flow of positive charge. But what kind of charge does an electron have? Negative charge. If the negative charge is going this way, then will the positive charge come opposite to it? Yes, sir. If the negative is coming this way, then the positive will come this way. And positive charge direction will be same as current direction. So if the electron goes like this, the direction of current will be like this, simple, opposite to the flow of electron. Anywhere beta, if you see an electron, if it's going in this direction, what will be the direction of the current? It will be opposite to it. Clear? Okay. The SI unit of current has been stated ampere, which is capital A. The board many times asks for a smaller unit of this. Which one? Microampere. It's written like this. Microampere and milliampere. It's written like this, MA. MA is milliampere. Milliampere. What is the meaning of milli? Milli means milli. 1 milliampere is 10 is to power minus 3 ampere. It is asked many times, milliampere. There is one more smaller unit, microampere. This is micro, the U1. Microampere. 1 microampere is even smaller, 10 to the power minus 6 ampere. So remember this, milli is 10 to the power minus 3, micro is 10 to the power minus 6. Okay, the current formula was Q. Come on, bhai, let's do a problem. CBSE 2024, what did they ask in the board? An electric source can supply a charge of 500 coulomb. So they gave us the value of charge. How much is it? 500. And we wrote capital C for coulomb. If the current drawn by a device is 25 milliampere, they told us the current. We used I for current. How much is it? 25 milli. Milli means 10 to the power minus 3. So let's write it down. 25 into 10 to the power minus 3 ampere. Now the third thing is left, T, that will ask. Find the time. So bhai, we have to find the time. So what will be the T? Simple formula is Q I P. Q is equals to IT. In place of Q we put 500. In place of I we put 25 into 10 to the power minus 3 into time. So bhai, pause it and comment with the answer. There are 4 options. I think the value of T will be 500 divided by 25 into 10 to the power minus 3. 25 into 2 is 50. So 20, and this will go up. And 10 to the power will be positive. It's negative below, so positive above. 10 to the power 3 means 1000. So 20 into 30, 20,000. Time unit is seconds. So option D is correct, 20,000 seconds. It was desert-like question. Come on, let's move forward. Now comes the potential difference. Is current understood? What is current? Q is equals to IT. Q, IT. Now we are moving on the next topic, potential difference. What is the potential difference? Let's say there are 2 points. Since it's called a difference, it's some difference between 2 points. Let's say at this point I have a charge of 1 coulomb. And I left this 1 coulomb of charge. We put in some effort, carry it like this and place it at the second point. I have 2 points, 1 coulomb charge. If I left this 1 coulomb charge, put in effort, carry it from here and place it to other point, then I will have to do some work. I will have to do some work in this, won't I? I will have to do some work, lift it, put it some effort and place it to other point. This work which we do, we call this potential difference. Simple. Potential difference between 2 points is the amount of work done. What is the potential difference? The amount of work. How much work had to be done. And moving a unit charge. Unit means 1. In moving a unit charge, that is charge of 1 coulomb. From one point to other. From one point to other. Let's say I have 2 points X and Y. So to pick 1 coulomb charge from carrying it from X and deliver it to Y, the work that we do as the potential difference between X and Y. This is the written potential difference between 2 points is the amount of work, how much work has done, how much work has done. And moving a unit charge, that is a 1 coulomb charge from one point to the other. Okay, understood. Now you have to remember its formula. Potential difference symbol is capital V. So I will write capital V is equal to work done per unit charge. Work done upon charge. Here W is what, beta? W is work done. What is work measured in? It's measured in joules. We use capital J. What is work measured in? Joules, capital J. Q is already know its charge. What is it measured in? Coulomb. So we can write capital C. And V is my potential difference. Now what is its unit of potential difference? The SI unit of potential difference is volt. And the symbol of volt is also capital V. The symbol that potential difference has, its unit the same, capital V. So V, the potential difference, and its symbol is volt, capital V. So you have to remember the formula. V is equals to W by Q. V is potential difference, W work done, and Q is charge in coulombs. Remember the definition. The board asks it many times. The definition straight up. The amount of work done in moving 1 coulomb charge from one point to other is called the potential difference between 2 points. It's between 2 points. Okay. There can be one more way to write this formula. That is, I can pick Q and throw it over this side. So can I write W is equals to Q into V? Is there any problem? W is equals to Q into V is easier to remember. What is W is equals to Q into V? What is W? Work done. What will it be measured in? Joules. Q is charge and coulombs. V is potential difference in volts. That's all there was to potential difference. Now look, what did CBSE 2025, that is this year's board exam, ask us? Define the term potential difference between 2 points in an electric circuit. Here it is. Potential difference between 2 points is the amount of work done in moving a charge of 1 coulomb from one point to the other. Name and define its SI unit. What is it? SI unit? Volt. The ask to define the definition of it, I'll tell you that later. I'll make you memorize the SI unit of everything at the end of the chapter in a very good way. Don't worry. We named it volt and I teach the definition of all of them at the end. Also express it in terms of SI unit of work and charge. In terms of work and charge, it's work done upon charge. Simple. If it asks an SI unit, what will you say? Joules upon coulomb done. Okay, bhai, let's move forward. Come on, a question has come. Calculate the amount of work done. Tell me, bhai. They've asked for work. Comment the answer after pausing. It's an easy question. By a cell, when 20 coulomb of charge, they've told us Q, how much is it? 20 coulomb. Yes, master. Is moved through a potential difference. PD means potential difference. Potential difference of 3 volt. Don't think about it, PD. Potential difference V is how much? 3 volt. They've asked for W. Use whatever formula comes to mind. I remember W is equals to Q into V. They've asked for work. Q is 20. V is 3. 20 into 3 is how much? 60. And what should the unit of work done be? Joules. Look, is 60 here? Here it is. The correct option is C. Easy busy question, bhai. Come on. Why did I teach potential difference? That's also a question. Listen one thing. Current only flows when there is a potential difference. When there is a difference in potential, then current will flow. Let's say these are 2 points beta. These are 2 points A and B. A potential difference, right? Let's say potential is 5 volt and its potential is 5 volts too. So what is the potential difference? What is the difference? 0. No current will flow. Absolutely no current will flow. Now let's say the potential is here is 15 and here is 5 volt. Now current will flow. Current only flows when there is potential difference. That's why I say, why does current flow? Because of what? Potential difference. Who is the father of current? The father of current is potential difference. If the father isn't there, how will the child come? So beta, it's necessary for the father to be there. Potential difference must exist, then current will flow. Otherwise, current will not flow. Okay. Now let's understand the story of potential difference. Who provides potential difference? Who is it makes the current flow? The battery or cell. So let's say you have this electric cell. It's also called dry cell. This is a cell. You've seen cells at home too. You use them in flashlights, remotes, etc. One side is marked positive and the other is negative. Right. This side, this is what? Conductor. This side of the conductor is connected to the positive. So I'll put a plus sign here. Here I'll put plus. And this side of the conductor, this is a wire. This side is connected to the negative. So I'll put a minus sign here. Now tell me, will the plus side is high or the minus side is high? Obviously the positive is bigger. So we call this higher potential, HP. What do we call it? Higher potential, that is HP, higher potential. And where it's negative, we say it's low. So we call this the lower potential, LP. Okay, where it's positive, it's higher potential. Where it's negative, it's lower potential. Give me an answer by pausing the video. If there is an electron here, where will it go? Towards the positive or towards the negative? Master, there's very easy. The electron has negative charge, so it will run towards the positive. Now look at the line up here. Electrons flows from lower potential to higher potential. You must remember this. Where does an electron flow? From lower potential to higher potential. Okay, so can I write this in brackets here that the electron flows from where to where? From lower potential to higher potential, right? Towards the positive. Higher potential means it goes towards the positive. Now if the electron is going this way, how will the current go? It goes the opposite way, sir. The direction of current is opposite to the flow of electrons, sir. So will the direction of the current be this way? Absolutely, sir. So current flows from higher potential to lower potential. Current flows from higher potential to lower. So write it like this, HPA to LP. Now, so you don't get confused with exam, just remember this one, current. It's very simple. Where does anything flow from and to? From higher to lower. By where does water flow from and to? From a higher height to a lower height. Where will you roll down from? From the top of the stairs to the bottom of the stairs. You won't get from bottom to top. So anything goes from higher to lower. Remember it. Current flows from higher potential to lower. In the exam, they ask about electrons. We know current and electron are opposite. Like this. No master, no dancing. Like this. Again dance. It's like this. So if they ask the electron, it's lower to higher. And for current, remember, where does anything flow from and to? Higher to lower. That means beta current will only flow if there is a difference in potential. If the potential becomes the same, the current does not flow. Okay, you will remember that. Now this is the symbol of cell. It's very simple. Like this, like this, like this. This is the positive terminal of the cell. This is the negative terminal of the cell. Something will be written here that this cell is 1.5 volt cell. So how much potential difference will it give? It will give 1.5 volt potential difference. Let's say we connected many cells together. Combination of cells. What do we call this? We call this a battery. Generally, what do we people do? You call even one cell battery. When we combine many cells, we call it battery. How do they connect? Look, what do we do? It's positive, negative. Its negative is connected to the positive to the next one, negative. Its negative is connected to the positive of next one, negative. Its positive is connected like this. So the long line in the positive higher and the short line is the negative lower. So drawing a cell become very easy. Draw like this. A long line means positive, a short line means negative. To connect cells, connects the short one to the next one long one, then connects the short one to the next one long, connected short one to the next one. What has this become beta? What this thing become as? What did we make? we can call this we call this battery. Understand one more thing. Let's say below this it's written 1.5 volt, below this also 1.5 volt, below this also 1.5 volt, below this also 1.5 volt. So how much total potential difference is the battery giving? 1.5, 1.5, 1.5. It's 4 times. So let's add them up. 1.5 plus 1.5 plus 1.5 plus 1.5. So the total is how much? 6 volt. That's why we connect cells to get a greater potential difference. Greater potential difference means more current will flow. That's why make a battery. So you understood the cell, one long line, one short line, positive, negative. And if we connect many cells together, remember how they are connected? Positive, negative, it's negative to the positive of the next one. Negative, it's negative to the next one, positive. That's how we connect. And what did they become? They become a battery. And the potential gets added up. Let's move on. The next thing that came up is our resistance. Resistance, its symbol is capital R. That's a lot of confusion happening. We studied a lot. Don't worry at all. See what all we studied. You studied current, Q, I, T. Q is charge in coulombs, current in amperes, time in seconds. You studied this one. You studied potential difference. For that, W is equals to Q into V. W is our work. What is we measured in? Joules. Q is charge in coulombs. And V is our potential difference. What is in measured in? Volts. We'll only study 2 formulas. Don't worry. Come on, bhai. Let's move forward. Next up is resistance. Capital R is its symbol. Capital R. Remember. Now, what is resistance? Imagine that inside a wire, inside a conductor, current wants to flow. Current flow means electron flow. If the electron flow this way, the current will move opposite to it. That we know. But when the electron wants to flow inside the conductor, beta, it faces a lot of hitting and fighting. In school, when your recess happens, it is very crowded the moment you move out of class. And if you try to run, what happens? You're running and crash into dhadam. And you're running into dhadam. Sometimes you accidentally bump into the wall. Some friend push you to make you bump into the wall. That's a wrong thing. Very bad. Behave yourself. Does that happen? Sir, they push like this. Hey. So what happens if you want to run faster, a place which is crowded? You will bump and crash, bump and crash. So your speed will slow down. You will move a little slow. So you will say, hey, people are doing what with me? Stopping me. They are obstructing me. People are trying to stop me. They are giving me resistance. This is what we call resistance. Let's say there is an electron, not one but many electrons. Look, I can see the electrons here. They are electrons. What color I should take? Black. Look, electron. This is also an electron. This is also an electron. Now this electron is moving from this side to this side in conductor. Why is it going? Let's assume there is negative. Let's assume there is negative here. Let's assume there is positive here. Where will the electron go? Towards the positive, towards the higher potential from the lower potential. The electron wants to go towards the positive, it wants to go. But when electron started moving, bhai, what is the conductor wire made of? It's made of copper. We have copper wires, right? Now, if the wire is made of copper, it will have a small, tiny atoms will be there. So look at these red ones. They are the small copper atoms. Now, when the electron tried to move, what happened? It hit the copper atoms, Alakh. Hit the copper atoms, Alakh. And what does it do to him? Copper atoms reduces the current. Try to stop it. The more the electron flowed, the more current would be in the opposite direction, of course, in the opposite direction. But the more the electron flowed, the more current would be. But the atoms inside the conductor, actually, they are ions, but you can stick with atom. What are those atoms doing? They are stopping the electron. What is happening? The electron moves, crashes into this. It says go, 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 hate. Go, 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 hate. Go, 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 hate. And in all this fighting and clashing, what did it get? It got an obstruction. What did it get? Obstruction. It got an opposition. Something is stopping it. This is what resistance is called. Property of a conductor to oppose the flow of electric current. Resistance stops the electric current from flowing. Property of a conductor to oppose the flow of electric current. Oppose the flow of electric current. Okay. Now, what is the formula of resistance? Let's say I have a conductor here and its length is L and its area of cross section. Cross section means let's say this was my conductor. Then this would be its length and this area of this is called area of cross section. This area. So its area of cross section is A. So resistance depends on 4 factors. The board asks this too. It's important. First thing, it depends on length. How? Beta, resistance is directly proportional to length. The longer the wire, the more fighting and crushing will happen, the more the resistance. Second, on area, on this area, resistance is inversely proportional to area. The greater the area, the less the resistance. By the greater the area, the more space the electron will get to move out. The greater the area, the less crowd will be. There's more area, they will find ways to get out. So the greater the area, the less the fighting and crushing, the less the resistance. The third thing is that it depends on the material. Now what does this mean? It's very simple, beta. You have seen that wood doesn't allow current to flow. But if I talk about iron or copper, metal, current flows in that. That means it will depend on some material as well, how much current will flow. Current doesn't flow in plastic. But if I pick up a metal, current flows very well in silver. So there is one more thing on which resistance depends, which is material. Resistivity, rho, property of the material. What is it? Resistivity. One more thing has come up. Resistivity, we will study this later too. So it depends on one more thing, resistivity, its symbol is rho. So resistance depends on resistivity. How does it depend? R is directly proportional to rho. The greater the resistivity, the more the resistance. The greater the stopping ability, the more the resistance. Okay, let's make the formula for resistance. See, directly proportional to L, inversely and directly. So the formula is very easy. R is equal to rho L by A. If you grab this formula, you will write the rest to yourself. Where is L? In front. Where is A? Down. Where is the resistivity? In front. R is equals to rho L by A. You should remember this. It depends on length. It depends on area. It depends on resistivity. It does not depend asked in the board. Shape is not talked about anywhere. So this one more thing which resistance depends, which is temperature. Now, how does it depend on temperature? You have to remember this. Generally, increasing the temperature increases the resistance. Generally. So, generally you remember that if you increase the temperature, resistance increases. What's the formula? Rho L by A. Temperature isn't anywhere in the formula, but it depends on temperature. What is a thing called rho? Rho is resistivity. We'll teach about that properly. L is what? Length. A is what? Area. Okay. Now look at one thing. What should the length always be in? Always keep it in meters, beta. It's a distance, right? What should the area be in? Keep it in the SI unit, meter squared. And when you do all this, what will the resistance be in? What is the unit of resistance? The SI unit of resistance is ohm. And its symbol is this, omega. Ohm. And its symbol is this one. This is called resistance unit, ohm, or this symbol omega. So what does resistance come in? Resistance come in OHM, ohm, or you can write this as an or. So you must have a friend whose name is ohm. Do you or don't you tell me his full name? Yes, bye. So the unit of resistance is ohm, or make this symbol. Okay, good. Rho is resistivity, L is length, A is area. Okay. Resistance increases on increasing the temperature. I said generally. Why I said generally? Look, I bought it here. Now look. If you increase the temperature, let's talk about metals, copper, silver, iron, their resistance always increase. If you increase the temperature, if I talk about alloys, you studied alloys in 9th grade. This year also will study in chemistry. Made by combining two metals. Like nichrome is an alloy. They ask about this, made of nickel and chromium. Nickel, chromium, nichrome. Nichrome is an alloy. It's formed by mixing two metals. On increasing the temperature, the resistance of alloys also increases. It increases little less. Theirs increased more. Theirs increase a little less, but it does increase. But if you have a new thing, a semiconductor, if you have something like carbon or silicon, the resistance can even decrease on increasing the temperature. I want to tell you this. The board hasn't asked this one yet. It has asked these two. So for your syllabus, you can say that on increasing the temperature, the resistance increases, it increases. But if someday it asks carbon or silicon, increasing temperature resistance, decrease. That was small thing, it's corner case. Let's focus on the main case. The main case is R is equal to rho L by A, and the unit of R is ohm, or this symbol. The exam asks one thing a lot. The rho that you are writing, the rho. What is resistivity? Unit of it. Tell me the unit of this resistivity. So we will derive this. Let's derive it. If R is equals to rho L by A, then can I write rho is equals to, say it. Can I write rho is equal to R A by L? Any problem? Rho is equal to R A by L? No problem. Tell me what is the unit of R is ohm. This has to be drawn, right? Like this, like this. The girl with beautiful hair. Yeah, the ohm. Yes, beautiful hair. What will be the unit of area? Meter squared. And what will be the unit of length? It will be meter. This 1 meter gets cancelled out. So what is the unit? Ohm meter. This is the unit of resistivity. The exam asks it, it's important. So say it's written here, the unit of resistivity rho will be that, tell me, ohm into meter, and the resistance unit is ohm. Clear? R is equal to rho L by A. Let's do a question based on this. Now based on R is equal to L by A. CBSE 2023 asks you the resistance of a wire. It told us there is a wire. Does not depend on, it does not depend on what? It depends on length, it depends on area, it depends on material, resistivity. It does not depend on shape. So this will be a correct answer. Next, ask in CBSE 25, ask in 24, ask in 23. This question is being asked almost every year because many sets of papers are made, so it asks it somewhere or the other. Write the relation between resistance R and electric resistivity of the material of a conductor in the shape of a cylinder of length L and area of cross section A. It simply asks you for the relation. R is equal to rho L by A. Hence, derive the SI unit of electrical resistivity. It's asking for resistivity, this rho. Derive what? The SI unit. Derive it. So what will you do? Rho is equals to, what will you write? R A by L. The unit of R is ohm. This is meter squared. This is meter. One gets cancelled. What will come? Ohm meter. Clear? Come on, let's go ahead. Now comes resistivity. Yes, bye. What is the resistivity? Property of the material. Only material's property, beta. Only the property of the material. Property of material. Let's say I have a copper glass, a copper jug, a copper wire, a copper room, a whole wire made of copper. The resistivity of all of them will be same. Because resistivity only depends on what? Only on material, and it doesn't depend on any other thing, beta. Only on material. It does depend on temperature. That's the same as the resistance one. The temperature part is the same. But it's on length, area, diameter, radius, shape. It does not depend. Resistivity is a property of the material. It does not change with the shape and size of the material. Like length, area, diameter, radius. Who does it depend on? Who does it depend on? Resistance does. Resistivity is only of the material. If I tell you that I am giving a silver wire, now you can stretch that silver wire as much as you want, press it as much. You can make a flower out of the silver wire and give it to her, madam. The resistivity, all of them will be same. Next, let's understand the order of resistivity. The highest resistivity means the property to stop the current. Yes, this is also same. The property to stop the current. Whose resistivity will be the highest? Insulators like plastic or wood. Their resistivity is the highest. They will stop the current. Whose is less than them? Alloys. And the least metal, copper, silver, theirs will be least. They are very good conductors, won't they? The greater the resistivity, look at the formula of resistance. R is equals to rho L by A. The greater the resistivity, the greater the resistance, right? So the resistivity of insulators is very high. The resistance is also very high and current does not flow. And the resistivity of metals is very low. The resistance is also very low. That's why current flows perfectly. Now, based on just this concept, a question was asked from you in CBSE 2025. They gave you three materials and ask you tell which one is a metal, which one is an alloy, and which is insulator. Comment and tell me. Comment after pausing and tell me. Let's see if you got it or not. Let's see if you got it or not. If you got it, comment master, I got it. Which one of these is a metal, which one is alloy, which one is insulator? Look. The resistivity of a metal will be the lowest. Which one is the lowest among this? This is what? This is very high, 10 to the power 17. 10 to the power minus 6 is very less. This is the smallest, 10 to the power minus 8. When a minus sign is attached to the power, it gets smaller. Which is bigger than minus 6? Which is minus 8. When 10 to the power is applied, it gets smaller. Bigger means smaller. The more the negative power, the smaller it is. So the resistivity of C is the lowest. So C will be my metal. After that, resistivity of B is low. B is my alloy. The resistivity of A is the highest. So A is my insulator. Look, this is same question lifted from theory and asked by CBSE. Where the resistivity is highest, that's an insulator. Where it's lowest, that's a metal. And the metal one is alloy. Okay, bhai, understood very well. Next. Insulators like rubber and glass have high resistivity. That's why they are poor conductors. Rubber, glass, wood, plastic, their resistivity is very high, so they are poor conductors. The SI unit of resistivity is ohm meter. Okay. Copper and aluminum are used for transmission lines, meaning for sending current. Why? Because their resistivity is low. If someone asks why, just say their resistivity is low. That's why they are used. The resistivity of metal is low. Now you need to trust two devices. One is the voltmeter. Now the word volt is the name of the voltmeter itself. What does it measure? Potential difference, right? Potential difference is measured by an instrument, the voltmeter. If you see written inside a circle, understand that it will measure potential difference. Remember the name voltmeter. And the other is ammeter. Now this ammeter, ampere, yes, it measures current. Electric current is measured by an instrument, ammeter. If an instrument has an A written is like this, what will it measure? Current in amperes. If it has V written, potential difference in, clear, you have to remember these two devices, V for potential difference, A for current. Let's go. The question from 2025, 23, 22, 21, you must do this question, pause and comment the answer, pause, comment your sworn to them, whoever you have a crush, and if you break your promise, may God ensure to of you never speak again. Pause and comment. Then, okay, let's go. The resistance of a metal wire of length 3 meter, they have given me a length 3 meter, is 60 ohm. How much is the resistance? 60 ohm. Okay. If the area of cross section of the wire area is given as 4 into 10 to the power minus 7 meter square, calculate the electrical resistivity. It asked rho value to us. It's an easy busy formula based question. The formula of resistance is R is equal to, say, rho L by A. What have they asked me? They've asked me for the value of rho. So let's keep rho here and send everything to other side. Rho is equals to, this went over there, RA by L. Come on, now put the value. What is the value of R? 60. What is the value of A? 4 into 10 to the power minus 7. And what is the length to be kept down? 3 meter. Look, 3 will cut this. 3 ones are 3, 3 to the 6, 20. 20 into 4, how much is it? 80. 80 into 10 to the power minus 7. And what will be the unit? The unit of resistivity? Ohm meter. It asked this many times. Remember, ohm meter. If you want to write this like this, generally what people do, they send 1 0 over here. So it will be 8 into 10 to the power minus 6 ohm meter. There is one extra 0, so it goes adds up here. When it's add, minus 7 plus 1 is minus 6. Next is, how will the resistivity of the wire change if the length and diameter of wire both are doubled? What did they do? They doubled the length. They made the length 12 and the diameter is something we'll see later. They made it 2d2. They are asking how the resistivity will change. Say, resistivity will not change until the material changes. Resistivity is a property of material. Length, area, shape, size, diameter, radius, it makes no difference. Resistivity is a property of material. It does not change with shape, size of material. And what changes? Resistance. Resistance changes, that depends on length, area and everything. Come on, bhai, let's move forward. CBSE 24, 22, 21. This is an exactly similar question is asked repeatedly in the board exam. In the following figure, 3 cylindrical conductor A, B, C are shown. If they are made of same material, look what's the biggest hint here. If they are made of same material, if all three are made of the same material, then what thing will be the same of all three? Resistivity. So the resistivity of this rho, this is also rho, this is also rho. Yes or no? Same material. Find RA upon RB and RA upon RC. I need to find the ratio. Pause and comment. It's an easy busy question. Come on, I'll find it. Resistance of A. Resistance formula rho L by A. By what will be the formula of resistance? Let me write it here. Tell me the formula of resistance. Rho L by A. Come on, let's find the resistance of all three. So I'm finding its resistance rho. How much is the length? L. Area is how much? A. And let's find the resistance RB. Rho length is how much? L by 2. Area is how much? 2A. So beta L by 2, the 2 will come down. It will be rho L upon 2 got multiplied with this 4A. This become RB. Now let's calculate RC. RC is rho. How much is the length? L by 2. Area is how much? A by 2. Look, 2 and 2 will be cancelled. There also upon, below is upon, cancel. So how much is RC? Rho L by A. Now what I have to calculate? RA by RB and RA by RC. Calculate this immediately. This is very easy. RA upon RC. Now look carefully. How much is RA? Rho L by A. How much is RC? Rho L by A. So beta this will be cancelled. How much is the ratio? 1:1. It is 1:1, 1 by 1. Both are equal. RA and RC are equal. The second thing, ask RA by RB. RA by RB. What will this be? Come on. What is RA? Rho L by A. What is RB? Rho L by 4A. If you look carefully here itself, rho L by A. If I call it X, then rho L by 4A won't be X by 4. If this is 1, is this 1 by 4 or not? It means this. If on place of RA I put X, this is how much? X by 4. 4 times less. X and X cancel. The 4 goes up. What is it? 4. You can write 4 by 1, or you can just leave it as 4. Or you can put full thing. Put rho L by A on top. Put rho L by 4A on the bottom. Rho L by A cancel out. The 4 will go up and this will come. Is it clear, bhai? Let's move ahead. CBSE 21 is asking what? Its question again. A wire of given material having length L and area of cross section A has a resistance of 4 ohm. The resistance has shifted a little here. Has a resistance of 4 ohm. Find the resistance of another wire of the same material. Same material means what is the same for both these materials? Resistivity. This is rho. This is rho. Find the resistance of another wire of the same material having length L by 2 and area of cross section 2A. So we have one wire whose length is L, area of cross section is A, and its resistance is given as how much? How much is the resistance given of this? Its resistance as given to me is 4 ohm. And it's asking me what its resistance will be for another wire of the same material with L length L by 2 and area 2A. So what will be resistance here? Now there are two ways to do this. Either write the resistance formula for this one, write this formula and divide them, which is long method. Grab a shortcut method. What is the same of both? Rho is the same. If I take the formula for rho, what's the formula of rho? Sir, how do we calculate rho formula? It's easy. Tell me our formula. Rho L by A. From here, what is the formula of rho? R A by L. Yes or no? Rho L by A. Rho's formula R A by L. It means if I tell you this I take as A and this I say B, so the resistivity of A is equals to resistivity of B. Any problem? No, because these are same materials. Tell me the resistivity formula. R A by L. How much is the R? 4. What is it say? A. What is it cell? L. Tell me. The resistivity of A will be this R A by L. R is 4. Area is A. And the length below is L. Resistivity of B. Formula. R A by L. Its R is unknown. Its area 2A. Its length below is L by 2. Look, this has made it very easy. So this is 4A by L is equals to, this 2 went up, 4 times of RA by L. Yes or no? This 2 will go up. Now look from A, sorry, went wrong here. You, master. Yes. Now look. Yes. Now look, from A will die from A, L will die from L, 4 will die from everyone die, master. So nothing is left in front of R. Nothing left means 1 not 0. So what will be the resistance be? 1 ohm. This is the simple method. As soon as it's at same material, I wrote resistivities of both equal to each other. I made the formula for resistivity RA by L. I put R A by L for this one, R A by L, and after that R came out. What could be the other way of do it? Hey, R, the other way could be that RA, what? Rho L by A, and then you write RB. Rho length was how much? L by 2, and the area was how much? How much was the area? 2A. So rho L by 2 upon 2A. Then you divide RA by RB, and then value of RA was known. The value of RB will come out. You can do it. It will also cut down. This is also a method. This is a bit lengthy. Is that clear? It's easy. That one was easier. It was done quickly. Its value was known 4. All of them would cancel out and would get the value of RB. Okay, bye. Let's move ahead. Now understand one thing. Diameter came up in the middle. Yes, now understand. Let's say this is a cylindrical conductor. It looks like a cylinder. Its length is A, L, area is A. Now beta, when anything is circular, its area looks circular. Whenever anything circular, does it have some radius? Absolutely. And does it also have diameter? Yes, sir, absolutely. If I ask for the relation between diameter and radius, you will all know that radius is half of the diameter. Okay, sir. Let's say the exam doesn't give you the area at all. It gives you radius and diameter. Then will you be able to find the area? Absolutely, sir. What is the area of circle? Pi r square. By how much will be this area? Pi r square. So the resistance formula, rho L by A. What do you put in place of A? Pi r square. So rho L by pi r square. That's it. This area will be pi r square. If the exam gives the radius or diameter, how will you find it? If he gives the diameter, first find the radius from the diameter. Then with the radius, find the area and here put it. Okay. One thing is very important. Generally, people miss this. It's an important lesson. Resistance is directly proportional to length. That's correct. That's correct. If I double the length, the resistance will also double. It's directly proportional. If you double the length, resistance will double. If you halve the length, resistance will halve. Let's say I make the length L by 2. Then the resistance will become R by 2. I divide the length, the resistance doubled. I halve the length, resistance also be half. Why? Because it was directly proportional. Listen to opposite. Area is in opposite to it, x at bottom, written at bottom. If we double the area, the resistance will become half, x inversely proportional. So I double the area, the resistance, R by 2. And let's say if we halve the area, then think the opposite. It's the opposite. Look, it is inversely. If we halve the area, the resistance will double 2 times more. Okay, that was very simple. Very simple, simple. L and A have seen by face to face. This is directly proportional. Double the length, resistance doubled. Half the length, resistance half. Very simple. If we talk about area, doubling the area is the opposite. Resistance half. Half the area, resistance doubled. Now listen carefully. If they ask you for radius or diameter, and they do ask, now look carefully from here. Resistance is inversely with R. Inversely meaning opposite proportional. Opposite. If I write the proportionality for R, will I write R is proportional to 1 upon R square? Do you see it? What did I put in place of area? Pi R square. Do you see it? R proportional to 1 by R square. Yes. So it is the opposite. By increasing the radius, resistance will decrease. Are you getting this? But look carefully what will happen. If you double the radius, beta, if you double the radius, it is opposite. It is the opposite. So the resistance will be what on doubling? Half. It won't be half. The square of half. The square is a plate. Square. So the resistance will be what? What is the square of half? 1 by 4. So the resistance will become 4 times less. On doubling the radius, the resistance will become 4 times less. And think the exact opposite. If I halve the radius, half, it is inversely proportional. When halved, what would happen? It's opposite. Half, it would have doubled. But the square of double is 4. So the resistance will become 4 times. You must remember this thing. And this same relation that the radius has, the same relation is also for the diameter. The same relation is also for the diameter. Okay. Double the length, resistance doubles. Like doubling the area, resistance half. But doubling the radius, resistance becomes 4 times less. Do you remember the proportionality? It will become opposite on doubling. It should become half, but the square of half is 4 times less. And on half, it should have been double. The square double, 4. Okay. Now look at the question asked in CBSE 24. How much does the resistance change if the diameter of wire is doubled? Tell me quickly. If you double the diameter of the wire, what will happen to the resistance? Half? No. What will the resistance become? The square of half. 4 times less. So you will write the answer is resistance decreases by 4 times. Resistance decreases by 4 times. Right? You doubled it, so R by 4. Same thing for radius, same thing for diameter. The question was asked, I have done it. Come on. Now look, CBSE term 221-22. The resistance of wire of radius is given. The resistance of wire of radius, how much is the radius? 0.01 centimeter is 1 ohm. Is it 10 ohm? 10 ohm. Let's correct it here. How much is the resistance? 10 ohm. Okay. If the resistivity of the wire, resistivity is given as 50 into 10 to the power minus 8 ohm meter. Find the length of this wire. They've asked for the length. Let's assume it's 10, maybe it's something else. We assume 10 ohm. Okay. Now beta, what have they asked to us? Length. It's very simple. We have to apply the resistance formula. What is the formula? R is equals to rho L by A. But area is not given. What did they give? Radius is given. Radius is given. But if the radius is given, we can find the area. What will be the area? Pi R square. From here, you will find the area and put it in the formula. You know the resistance, you know the resistivity, you know the length, and the area will come out. What do we have to? Sorry, we have to find length. So you will be able to find the length from here, isn't it? Let's see. The value of resistance will be 10 ohm. Rho is given as 50 into 10 to the power minus 8. Length I need to find. Area will be pi r square. Now look, r is generally given in centimeters or millimeters. So you should remember one thing, I mentioned it before. Look here. R and D are given in millimeter and centimeter. Generally it's in millimeter and centimeter. If it's given in centimeter, how will you convert it? Multiply by 10 to the power minus 2, right? So it will change into meters. If it's given in millimeter, what do you multiply by? 10 to the power minus 3. So remember this, to go from centimeter to meter, it's 10 power minus 2. If it's millimeter, it's 10 to the power minus 3. The basic math, not physics. Yes. So beta, what will you do here? The radius is 0.01 centimeter. So 0.01 into 10 to the power minus 2 we will write. Now this is in, to go from centimeter to meter, it's 10 to the power minus 2. So beta, we can write 50 into 10 to the power minus 8. Length I don't know. There is calculation in this question. Shall I take the value of pi as 3.14 approx? It is not given in question, so I kept the value of pi as 3.14 approx. Its absolute value is undefined. Look, it's on my hand too. It is here. It doesn't have absolute value. Into how much is r? How much is r? How much is r? 0.01 into 10 to the power minus 2 whole square. Now look carefully, 0.01 into 10 to the power minus 2. Can I write this as 1 upon 100 into 10 to the power minus 2? These double zero will become negative, so they will become 10 to the power minus 4. Isn't that right? These are two zeros. When they go up 10 to the power 2, when it goes up, it becomes 10 to the power minus 2. 10 to the power minus 2 and 10 to the power minus 2 is 10 to the power minus 4. So can I directly put 10 to the power minus 4? It's all calculation. Look, 1 upon 100, this went up. So I put 10 to the power minus 4 square. But after this, you just have to do calculation. 10 is equal to 50 into 10 to the power minus 8 into L upon 3.14 and 10 to the power minus 4 square, 10 to the power minus 8. So this 10 to the power minus 8, 10 to the power minus 8 will cancel out. The 0 will cancel the 0. So the length is equals to 3.14 divided by 5. Here 0, 5, 6 are 30. This become 11, 5 2s are 10, 14. It will be 0.62 meter around will be answer. 0.62 meter approximate. Okay, so it was calculation based question. CBSE 2024. This question is homework for you. You have to comment the answer. It's very simple question. A copper wire has a diameter this time. They gave the diameter 0.2 millimeter. If this give millimeter, what you do? 0.2 into 10 to the power minus 3 meter. From here, the radius will come out. Diameter upon 2. Resistivity is given to you. You know rho. What will be the length of the wire? Length is asked. To make its resistance 14 ohm. So resistance is given as 14 ohm. What is asked? Length is asked. So you can do it. Comment the answer. Next part. How much does the resistance change if the diameter of the wire is doubled? Resistance is asked. Resistance. If I double the diameter, resistivity will not change. Resistivity is a property of a material. It absolutely won't change. But what will happen to the resistance? Double means half. No. The square of half will be what? Resistance will decrease 4 times, whether it's diameter or radius. Let's move forward. The next topic is our Ohm's law. Ohm's law is very important and very similar. Very simple. I told you at the beginning, the more the potential difference you apply, the more current will flow. This is Ohm's law. The more the potential difference, the stronger the father of current, the bigger the current. This is Ohm's law. Ohm's law says that, let's say there is a conductor. The potential difference is V. The current flowing is I. So V is directly proportional to I, provided the temperature remains constant. The surroundings temperature should not change. Under such a condition, V is directly proportional to I. Suppose V value is 2 volt and the current is 1 ampere. Let's assume. Let's say I double V to 4 volts. The current will also double. How much is it? 2 ampere. Let's say I triple the V, 6 volt. Triple it. Then the current will also triple beta. How much it will be? 3 ampere. This means V is directly proportional to I. However, many times you increase the potential, the current will increase by the many times. Is this Ohm's law? What? The potential difference VA across the ends of metallic conductor is directly proportional to the current, flowing through it, provided its temperature remains the same, provided the temperature remains constant. The potential difference V across the ends of a metallic conductor is directly proportional to the current. V is directly proportional to the current. So, by what is Ohm's law? V is directly proportional to current, provided there is only one condition, that the temperature must remain same. Temperature should not change. By many times the potential increase, the current increase by many times. By how many times the potential decrease, the current also decreases by many times. We have to remove proportionality and put the equal to sign. So when we wrote V is equal to, a constant came and the constant was R, resistance. Now our entire equation is complete here, and now you can do questions. Very good. V is equals to IR. We have to remember this equation. V is equals to IR. What is V beta? Everyone will remember. What is V? Its potential difference. What is it measured in? Volts. What is I beta? Everyone knows. Its current. What is it measured in? Amperes. What is R? Everyone knows R. Its resistance. And what is it measured in? Ohms. There is a way to remember this. V is equals to IR. You can remember it. Viral. So we can give it name. We can give it as viral equation. This equation is viral. V is equals to IR, viral equation. This is Ohm's law. But if Ohm's law comes in the exam, don't write this. Write this. This is absolutely correct. V is equals to proportional to I. Or write this. If it straight up asks you for the equation of Ohm's law, otherwise Ohm's law is this and the definition. V is equals to IR. Okay, look at one thing. Now I said for Ohm's law or for a metallic conductor, draw the graph of potential difference versus current. Now you learned in the 9th grade, and if you didn't learn now, whenever it's directly proportional, the graph beta is always a straight line passing through the origin. This. So this is graph of V versus I for what? For Ohm's law. The exam asks you to draw the graph of V versus I for a metallic conductor or for Ohm's law. So straight line passing through origin. This we have to draw always. Clear? Let's move forward. CBSE 24, 23, 20, 19, RRRRRR. The potential difference across the two ends of a circuit component is decreased to 1/3 of its initial value, while its resistance remains constant. Look, why is the resistance constant? Because the temperature is constant. If the temperature is constant, the resistance also don't change. What change will be observed in the current flowing through it? Tell me, bhai, what change will be there? What did it say? The potential difference across the two ends of a circuit component decreased to 1/3. V is become 1/3, V by 3. So beta, the current will also become 1/3, I by 3. They are directly proportional. The potential decreased 3 times, the current also decreased 3 times. If the potential increased 3 times, the current would also increase 3 times. Okay, so current will reduce 3 times. Name and state the law which helps us to answer this, to answer this question. Which law is it by? That's simple. Ohm's law, and you can state it. You've been taught the state. Look below, it's written the potential difference across the ends of metallic conductor is directly proportional to the current, provided the temperature remains constant. Okay, let's understand next thing. If you get the graph of V versus I, you got it. What will it look like? A straight line. Why? Because of Ohm's law. Ohm's law tells us what this graph looks like. A straight line, because V is directly proportional to I. Now listen. The slope of this graph, sir, what is slope? If you see any graph in life and need to find the slope, just do y divided by x. Why? We know which axis is this. Y. We know which axis is this, x. So to y divided by x. If I do y divided by x, is it coming out to be v divided by I? Absolutely. What will v by I? Sir, we don't know what it will be. Think for a moment. Is v is equals to IR? Viral. V is equals to IR. Yes. So v divided by I. Look here. V divided by I is equals to what? Resistance. So beta, what does the slope of graph gives us? It gives us resistance. Now what is the slope? Slope beta is the angle. This angle, the greater this angle, the greater the slope. For example, it's like this. The slope is less, more. The more this line lifts up like this, the greater the slope will be. Now question will be, this graph slope, the more it will be, it means that conductor resistance will be that much higher. The slope is giving us resistance. So the more the slope increases, the more resistance will also increase. Clear? Look, a question has come up on the CBSE 2024 and 2023. We are given the V versus I graph. We are told R1, R2, R3 resistance. Comment and tell the order. Which one is the biggest, which is smaller than that, which is smaller. Look, the greatest slope, meaning the largest angle, slope means angle. The largest angle is of this one. So this will be the largest resistance. So the largest is R3. After that, the slope of R1 is large. So then comes R1. After that, the slope of R2 is there. So then comes R2. So what will be order? R3 is greater than R1, greater than R2. It's very important. What do you get from the slope, the BI graph? Resistance. The greater the slope, the greater the resistance. Sometimes in the exam, they try to play a trick and reverse it. Hey, sir, they made the graph of I versus V. If the exam ever reverse this graph, just remember this. What will be its slope? 1 upon resistance. If the graph is reversed, the slope is also reversed. In this case, the greater the slope, lower resistance. It hasn't been asked yet, but it can be asked. It's an excellent question. The greater the slope, the lower the resistance. CI on the top. The game has been reversed beta since at the reverse slope. It's 1 divided by resistance. Now the greater the slope, the less is resistance. Generally it asks this one. This is more important. Let's move forward. I also showed you the board question that came from this. Next is Ohm's law and its experimental setup. If this comes in the exam, it will give 3 marks question to experimentally shown to the complete setup of Ohm's law. For that, we need to understand the diagram. Now, what is the diagram? First, we need to take a battery. Everyone knows how to draw a battery. A long line, a short line, a long line, a short line, a long line, a short line, a long short. This is positive, this is negative, this is positive, this is negative, this is positive, this is negative, this positive, this negative. It's done, big line. And you have to connect from small to large. Then we bring a wire, connect this. What did we connect? An ammeter. I told you, if you write A in the circle, it's an ammeter. Then we bring it along and connect a resistance. And then we take that resistance and what did we connect here? This is called plug key. We will study the entire circuit element later, one by one. What did we connect? Plug key. Plug key means when this dot is placed inside, it means it's on. Current will flow. If you remove the dot from inside, it's off. So when the dot is inside, it is on. If the dot is taken out, it's off. So current will not flow. This is a switch, right? We draw it like this. Now what is hanging below the resistance? This is a voltmeter. What does it measure? Potential difference. What does the measure? Current, ammeter. So below the resistance is voltmeter. You must draw this diagram in the exam. You will get full marks. Now let's understand how we verified Ohm's law. Let's assume each cell is 1.5 volts. By experiment must have been done, right? If that doesn't happen, 1.5 volt, 1.5 volt for each cell. Look, this has been asked in the exam. CBSE 20, 21, 21, 22, term 2. This question has come many times. We have connected 4 cells. You have to memorize this diagram. Sir, memorize even in physics. Yes, you have to memorize a little bit, everyone. You memorized ABCD, right? 1.5, 1.5, 1.5, I assume. Now, I do one thing. See what I'm going to do. Something great is about to happen. I did one thing. This is open, say. Now, I connected this wire. This one. Can you see it? You can't see a color. Let me take yellow. I connected it like this. When I connected it, look, positive terminal of the cell, the current comes out. So current started from here, I, round, it got into this. Current I went into the resistance, walked, current came I, and I came, here it is connected, current I. And how much current cell got back? I. Always remember the current that leaves the cell in the circuit is the same current that returns to the cell. Okay. At this time, we took the reading of ammeter and voltmeter. Ammeter will measure current, I, right? What will it measure? Current, I. And voltmeter, potential difference. We said what is the current? It's I. And we took the reading of V. We said what is V? It's V. We said very good. How much did we apply? 1.5 volts. Okay, very good. Let's take a value. We saw the current is how much? We assumed as 1 ampere. and our V is 1.5 volt, 1.5 volt battery is connected, cell is connected, the first cell is connected. These others won't be count. Why? Because the circuit came from here, from here, from here, from here and closed like this. Current will not go here, the current left. So these others haven't counted yet. Now we have to understand Ohm's law. So we did one thing, we cut the connection. And the next time we made the connection from here. We made the connection from here this time. Next time we took one more cell. We cut this one. Now the current came out from here, went into this, went to this, into this, into this, and the current beta started coming back from here this time because it is connected from here and it went back here. We look at the reading. This time there are two cells, 1.5 plus 1.5 is how much? 3 volts. And we saw that as soon as the potential doubled, the current also doubled, 2 amperes. The current also increased. Then we cut this part too. We said we won't come this way. We cut this wire from here, here, meaning we remove this wire. We remove this wire too. Now we connected this wire. Current come from here, went there, and came back from here and into this cell. This time we took the voltmeter reading. 1.5 is how much? 4.5 volt increased. How much? 3 times from here. And we saw the current reading also 3 amperes, 3 times. So this is experimental setup. We have to remember this. Put a dot here, only then current will flow. If you take out the dot, you won't get marks. Current will not flow. Volt beta is hanging like this. Okay, keep that in mind too. Let's move forward. Our next topic is combination of resistance. We need to understand 2 types of resistance combination. One is series and one is parallel. What is series? It's when you stick one resistor after one another. One after the second, second after third, just stuck in a straight line. This is called series. Okay. Now understand. Let's understand series completely. Now understand the story of series. Let's say current I came here. This one, current I. Now the current that passed through this is the same current that went ahead. The same current passed through this. The same current passed through this. Same current passed through this. In the series means one after other when you pull port. So remember that what is current in the series combination? Same. Current is same in all of them. Now let's talk about potential difference. Tell me V formula. Viral V is equals to IR. What will be V here? I into R1. What will be V here? And this what will be V? I into R2. And this what will be V? I into R3. This means that value of V inside each one will come out different. Let's say the value of R1 is 2. So how much it will be here? V. 2I. Let's say this is 4. So 4I. This is 6. 6I. This is V for everyone is different. So in a series combination, remember that. And all resistance. What is current? Same. But what is potential difference? Different. Okay. Now what if we have to solve a question? We don't want 3 resistance here. Let's see a circuit has 15-20 resistance. Tell us the total resistance. What? The total resistance, tell me this. Now in physics, instead of total, we call it equivalent resistance. We call it equivalent resistance instead of total. If the exam writes total, the meaning will be same, don't worry. Equivalent resistance means how much total resistance is coming. Tell us the equivalent resistance. We denote this equivalent resistance as RE. Equivalent resistance. If I remove all 3 and take only this resistance, it will do the same job that 3 combined are doing. The formula for the total resistance or equivalent resistance as series beta is very simple. R1 plus R2 plus R3. Master this, very simple. The game will change in parallel. Remember that what is the first identification of series? It will be current, it is same, and potential will be different. That's the identification. Current will be same and potential will be different, same current. Next comes the parallel combination. You know that parallel looks something like the parallel lines. It's looking like this, one on top of one on top, one on top. And all the resistors are connected at common point. Isn't that right? R1, R2, R3. Here it is connected with point A. Let's assume and R1, R2, R3 are connected at B point. Let's assume, my bhai, if I current comes from here, the current will come here and said, where should I go? I have 3 paths. Here the only one path. I have to walk on one. Where should I go? 3 paths. So some current will go here, some current will go here, some current here. That is the same current. Will not flow in all 3. It was divided. Think suppose 6 ampere were coming from here. It's possible that 3 ampere went here, 1 ampere went here, 2 ampere went into this. Equal division, not necessary. Equal division is not necessary. So in parallel, the current is different. It can be the same too, but it will be different, right? When it will be the same, suppose all three are equal, then the current also divides equally. But generally, current is different in all of them. Now, let's talk about potential difference. Think and say it. The answer is simple, different. They are same here. Think about it. One point A, one point B. There will be some potential difference between A and B. Potential difference is between what? Between 2 points, isn't it? So let's say the potential difference between A and B is 10 volts. Let's assume. So across the R1, what's the potential difference on R1? R1 is connected to A on one side, B. So its potential difference is 10 volts. R2 is also A one side, B one side, 10 volts. R3 is also one side A, one side B. And the potential difference between A and B, potential difference is defined on 2 points. Points are same for all three. Since the points are same for all three, what will be the same of all three? V is same. So it's the exact opposite. Their current is same. Here V is same. Okay. Now if I say remove these three resistance and tell me one single resistance, equivalent resistance, why didn't I say total? Because adding them doesn't give total. The formula here is a bit strange. 1 upon total resistance, here R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now the very noob students, what do they do? 1 by R equals to here like this, here like this, here like this. I call these being no by. It's okay, a lot happens in life in big cities. Sir, we don't live in big city. These are big talks in our small cities. Okay, don't worry. This is absolutely wrong. Okay, if someone tells you this, smack them. Yes, no sir, non-violence. Don't hit him. 1 by RE is equals to 1 by R1. Whatever value this is divided by 1 plus, whatever value is this divided by 1 plus, whatever value is this divided by 1. After adding this, answer will come 1 by R equivalent. We'll show you plenty of practice now. How to identify them? The potential difference is same, then parallel, and the current is same. You can see in series. Here R1 plus R2 plus R3, there the formula is bit strange. Come on, let's do it. Find the equivalent resistance between X and Y. Now X and Y are 2 points, the potential difference between them. We will do a lot of practice now. Let's start. What will be the potential difference? Sorry, equivalent resistance will be what? It's clearly visible that these two resistance are in parallel. Is there any confusion? There shouldn't be. Look, current I will come from here. Some current divide here, some here. So the current is different. Their two resistance are between the same 2 points. So the potential difference is same. Okay. Now we want equivalent resistance. So 1 upon R equivalent is equals to 1 by R1 plus 1 by R2. Calculate with simple formula. So 1 by R1, how much is it? 6 plus 1 by R2, how much is it? 3. What is the LCM of 6 and 3? How much it will be? 6 only. This will remain as 1 and multiply 3 with 2. Numerator also multiply with 2 itself. 3 into 6, done. 3 upon 6 means 1 upon 2. I can write this. But this is value of what? The value of 1 by R equivalent. Its value came out to be 1 upon 2. If we want R equivalent, we will flip it. Isn't that? If we want R equivalent, flip it. 1 by R value is 1 by 2. So our value of R will be 2. So its equivalent resistance will be how much by? Answer is clear. 2 ohm. Come on. Now mixing starts. Now by there is series and parallel too. Look carefully. You must have figured it out. Think. Current I came out of here. Went. Some current went up, some current went here. The current that is flowing in the 8 ohm, will the same current flow in the next 8 ohm? Yes, bhai. Look, which will went into this same here. Means 8 and 8 you can see in what? 8 and 8 are seen in what? In series, one after other. And along with that, 16 is in what? It's parallel. These two are seen in series. So let's solve this first. I'll say 8, 8. Where do I see them? In series. So let's solve them first. How much will be R equivalent of series? R1 plus R2. In series it is R1 plus R2. So 8 and 8 is how much? 16 ohm. 16 ohm become equivalent of these two. If I redraw the diagram, it will look something like this. How much is on top? 16. Below, removing both of these. Can I write 16 ohm? Absolutely must have. Because the equivalent of those two came out to be 16, both in series. We remove them. Now these two are clearly visible to me. And what are they, sir? Parallel. I know the formula for parallel. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So the value of R equivalent will be 1 upon 16 plus 1 upon 16. LCM is 16 and 1 plus 1, 2 upon 16 means 1 upon 8. 1 upon 8 is the value of 1 upon R equivalent. If the value of 1 by R equivalent value is 1 upon 8, then the value of R equivalent will be 8 ohm. So the answer of this 8 ohm. Shall I tell you one shortcut? Do you feel from inside that you can hear shortcut or it's too much? You can listen, right? Yes. If you see equal resistance in parallel, their equivalent is half. If you see equal resistance in parallel, their equivalent is half. 16 upon 2, straight. All in parallel, not in series, only parallel. Next, what do we have this time? Again, something looks like series and parallel. Come on. The current I came out. The current goes and some it goes this way, some it goes this way. Okay, sir. The current got divided in both of these. Yes, sir. And do this two looks like in the series. Don't make this mistake of thinking that these two are in series. If you make that mistake, the master will come and hit you at home. Bhai, now think, suppose 10 amperes of current came here. Let's divide anything divided. Let's say 2 amperes went this way, 8 amperes went this way. Now look, 2 amperes went this way, went this way, went this way, come from top, came. 8 amperes came from here, 2 amperes came from the top, came, 8 amperes came. And here, 8 and 2 both met here. And how much did it become? 10. Now these two are not in series. Why they are not in series? Because this one has 8 amperes and this one is 10. Oh master, that didn't click. Master, what do we even tell us? We just accept it because you said so. Okay, master. But it's necessary to learn. That's why I said make a master out of you. Come here, my bhai. Come on, son. Assume here current. I assumed 10 amperes current. It will divide. Let me assume anything. I said 2 ampere went this way. I said 8 ampere this way. My choice. Okay, 2 amperes went this way. Going 2 ampere here. Coming 2 ampere. 8 ampere from here. Now these two currents will meet again here. Just as 10 divided by 2 is 8. 2 from this side and 8 from that. Meet here become 10 again. Now tell me, are this one and this one in series? Absolutely not, sir. The current is different in both. Go ask your teacher, ma'am, why we can't take this into series. If she tell you, then say her salam, ma'am, salam. Whether if she don't tell, then also salam because she has internal number. Do you understand the game? So don't think of these as series because the current is different in both. Ocha. Now understand, now we'll have to figure out things. I can clearly see one thing, that these two are in parallel. So first I will solve them. 12, 4 are in parallel. 12, 4 in parallel. So I'll apply the formula 1 divided by R equivalent is equal to 1 divided by 12 plus 1 by 4. The answer always comes out of 3, 12 and 4. Look, the LCM for 12 and 4 is 12. Here will be 1. 4 multiplied by 3 is 12. So 3, 4 divided by 12, 1 by 3. 1 by R equivalent value, 1 by 3. So what is R equivalent? 3. So can I remove these two and put 3 ohm? Absolutely I can. So what will I do? I'll remove these two from here and put 3 ohm in their place. What is ahead also? 3 ohm. Now these two are clearly visible to me in series. Why? Because the current I will take out from here won't split anywhere. The same current will go. These two I think are in series. If they are in series, what will R equivalent be? R1 plus R2, a straight up addition. I'll have to add it. So I'll do 3 plus 3. The answer will come out 6 ohm. This is our final answer. What was the equivalent of these two? 3. Then 3 and 3 are in what? Series. 3 and 3, how much is it? 6 ohm. So 6 ohm is the final answer. Okay, sir. Let's move ahead. Next, now look, a question came in CBSE term 2021-2022. Pause the video and comment its answer first. It's a very easy question. You will do it. Come on, bhai. I do it. Did you pause and comment? Yes or no? Please do it. Oh God, I have to give you an oath repeatedly. She'll die because of you. How much will you put another time? Yes. Here some current come. Here it's divided. Some goes here, then both will and came here. You must have understood by now that this not in series. That must have been clicked. That this and this is not in series because current will come from here, it will divide here, then we'll meet again. Okay. So and this current is not same. First, let's solve this. These two are clearly visible in parallel. So R2 and R3 are clearly visible to me in what? In parallel. R2 and R3 are clearly in parallel. 1 divided by R equivalent is equals to 1 divided by 10 plus 1 divided by 10. I said it 2 equals 2 are connected in parallel. What is the answer? It's half. You will see same will come. LCM is 10. 1 plus 1, 2. How much is it? 1 divided by 5. So look, what is the 1 divided by R equivalent? 1 divided by 5. So R equivalent will be how much? 5. We'll flip it. So the equivalent of these will be 5. Now it's very easy. Why? Look, what is connected here? 5. After that, equivalent of these two will be 5. What is ahead? 5. Now tell me, in what are these three things visible to me? Now it's clearly visible in series. The current that went into same went into this. Now R equivalent will be what? R1 plus R2 plus R3, straight addition subtraction. 5 plus 5 plus 5, what is the answer? 15 ohm. So what will be the answer be? 15 ohm. You must have done it yourself. Very good. Next. Now look, something like kite is made like this. I have two terminal points X and Y. Now in these two might look like the parallel, but they are not. Why? Always play the current, your question will be correct. Look, I'll make you realize right now. With this and this is not parallel. How? Look. The current game is the best answer, beta. Let's go. Suppose some current came out of here. How much? Whatever you want. Let's say 10 ampere. Okay. Let's say 10 ampere. I just assumed it. Assume 1500, whatever you want. Okay. Now some current out. Some went here, some went here. Value doesn't matter. Some went here, some went there. So I assume some went here 4 ampere. I assumed it. And 6 ampere went this way. It's assumed only. Okay. It is not calculated. Now the 4 ampere that came here, this 4 ampere will go there. Absolutely, sir. And the 6 ampere which went there, this 6 ampere will come here. Can we consider these two in parallel? No, sir. Actually, these two are in series and these two are in series. If there's a way to look at it, you can also look at it by tilting it like this. If I tilt and look at it, things will become clear. Look, nothing is connected here. Imagine it like this and it will look easy. Hey, like this. This, like this. 4, 2, and what is here? 2, 10. Master, you confuse me more. No problem. Look at it this way. This much we understood that these two are in series, same current. Look, whatever current comes from here, the current that goes into this, same current will go into this. So these two become my series. Similarly, the current divided from here, now the current that goes into this, the same current will go into this. So these two also become series. So let's do one thing. Let's solve the series first. So 4 and 2 are in series. 4 and 2 are in what? Series. So in series, what will be R equivalent be? R1 plus R2. So I straight added 4 and 2. How much did it come? 6 ohm. Similarly, 2 and 10 are also in series. So 2 and 10 are in what? Series. So R equivalent will be what? We'll straight add them. 2 plus 10. How much is it? 12 ohm. Now I'll do one thing. I'll remove these two and put 12 ohm. And I'll remove this 2 and put 6 ohm. This is X and this is Y. I draw the same way it was made. I will remove these both. When I remove this, can I? Like this. Remove both of them. In place 4 and 2, I'll put 6 ohm. Below, I'll remove 2 and 10. And in place of 2 and 10, what I put? 12 ohm. Now look carefully. These two look like they are in parallel. Now 12 and 6 are in parallel. 12 and 6 are in parallel. So what will be the answer? 1 divided by R is equals to 1 divided by 12. 1 divided by 6. What is the LCM? 12. This is 1 divided by R. What is the LCM? 12. Here it will remain 1. 6 by 12. 3 by 12. 3 by 12, which means 1 by 4. So R equivalent become what? 4. So its final answer came out to be 4. Tell me it's clear? First I solve these two series. Solve these two series. Then their answer is in what? Parallel. Great. Let's see the next question. Now look, CBSE has asked a nice question 2025 this year in the board exam. Determine the equivalent resistance of the combination between its two ends A and B. Here are the maximum number of students make a mistake in this question. A and B. One end is A. Sorry. One end is A and one end is B. We have to find the equivalent resistance between them. Now it feels like, dude, all these are in series or parallel. So I said there's only one way. Let's run current through it. Come on, I'll try current. I'll bring some current from here. How much should I bring? Whatever you say. 100 ampere, 10 ampere. Come on, I bought 10. Let's assume some went here. Let's say, what went? Let's assume 4 ampere. And 6 ampere went here. Right. The current came here and went in both directions. The 4 ampere that went into this, did the same 4 ampere go into this? Yes, master, it kept flowing. And when 4 ampere went into this, did the same 4 ampere go into this? Yes, master. And 6 came from here. 4 came from here. And combined both and 10 ampere came out again. The current which you put seems out of circuit. So great. So I understood that this, and this are in series. So I clearly understood that these three are in what? In series. So this 2, 2, 2. These are 3 invisible in series. What will R equivalent be? R1 plus R2 plus R3. They are equal value beta. 2. Add them up. How much it will be? 6 ohm. So can I remove these 3 and write 6. Look, I bought current from here, some went into this, some went into this. The one went into this, the same will go into this, same will go into this. Current is same. Current is same means tuck, 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 series. So this becomes series, add them up. Now can I remove these 3 and write 6 ohm? Absolutely. So this is A, this is B. What is connected above them? 2 ohm is connected. And in place of these 3, what did I write? 6 ohm. Now all this that was written here, that we assumed, you can erase it if you want. Okay, it was just explaining this. I don't actually know the current will be this. There's no battery, so how can I tell the current? It's not done like that. It's what just assumption. I just teach you. Come on. Now look, 2 is connected to what? A and B. 6 is connected to what? A and B. The endpoints of both are same. The endpoints are same, the potential will be same. That means it is parallel. Look, 6 is connected to what? A and B. So the potential difference in 6 will be the same as this. This is also connected to what? A and B. When 2 terminals are the same, the potential difference will be same. Now beta, for parallel, 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So 1 by R equivalent, how much is it? 1 by 2 plus 1 by 6. How much will be LCM? 6. 2 into 3 is 6. And here it will be 1 divided by 6. 1 by R equivalent is 4 by 6. If we divide 2 to the 4, so 2 by 3. So R equivalent will be what? 3 by 2, isn't it? Meaning 1.5 ohm, you can write. So R equivalent is, write 3 by 2 or 1.5 ohm. That is the answer. Let's move ahead. Now some important notes. I'll explain some concept to you. You have done a lot of questions, solved numericals, you started enjoying it and you started understanding it, you are getting the game. Let me tell you one thing. If there are 2 resistors and you connect them in series, like 6 and 3, what will the equivalent be? Series is simple, R1 plus R2, 6 plus 3, how much? 9 ohm. Okay. And if I connect them in parallel, like I have connected here, if I connect them in parallel, I'm telling a very important thing, very important thing I'm telling. Listen carefully. Here these 2 are in parallel. If I find the equivalent here, 1 by R equivalent is 1 by R1 plus 1 by R2. I'll put the values 1 by 6, 1 by 3. Answer will be 3 in parallel, 6 and 3. So 1 by R equivalent, the LCM is 6. This will remain 1, 3 to the 6. 3 upon 6 means 1 upon 2. So how much R equivalent is coming? 2 ohm. Now look carefully. The R equivalent in parallel becomes less and the R equivalent in series is more. No matter you have 2 resistor, 3 resistor or 10 resistor. Of that series combination resistance, it will always greater than parallel. That is written here. If you want more resistance, connect them in series. And if you want the total resistance to be less, then connect them in parallel. Should I say one more line? Should I say it? Will you be able to handle it? Handle it. Listen carefully. The total resistance of a parallel combination is lesser than the least resistance in the combination. The total resistance of a parallel combination is lesser than the least resistance in the parallel combination. Its total will be smaller than smallest resistance of this parallel. You can check in the exams. If you have 6 and 3 here, the answer will always be smaller than 3. Always. The answer always comes out to be even smaller than smaller one. The resistance decreased in parallel and increases in series. So in the exam, never ask you. You say it right. When 2 are connected in series, the resistance came out to be more. And when connected in parallel, the resistance become what? Less. And in parallel, it becomes so less that it came out to be even smaller than smallest one. So in the exam, if ever ask you that we want maximum resistance. For maximum resistance, how will you connect them? How will you connect them? Always in series. It will increase. And if the exam ever tells us that we want minimum resistance, make the resistance as minimum as possible, then how will you connect them? In parallel. Questions also come on this. Whenever it asks maximum resistance, in what we should connect them? In series. And it asks for minimum resistance, then connect them in parallel, the resistance will decrease. Look at the second important note. Nothing here, talk a small trick. There is a formula. It doesn't give an NCRT, but it's very simple. When R1 and R2 are in parallel combination, so how do we get it? 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Then the answer that comes, we flip it. So it has a simple hack, a small shortcut, that R equivalent is equals to R1 R2 upon R1 plus R2. Now the formula seems tough, but it's very easy. What? Multiply both on top and add both on bottom. If there are 2 resistance, multiply them on top and add them on bottom. Parallel R equivalent comes. It's a shortcut to get the parallel. Because that method is very lengthy. It is very lengthy, 1 by R, 1 by 1. So shortcut is multiply upon lower hat. If you want to test it on this. You have found it 6 and 3. Find it from here, multiply both on top, add both on them bottom. So 6 into 3 and 6 plus 3. Remember it like this, multiply on top, add on bottom. So 6 into 3 is 18, 6 into 3 9. Divide it, how much you get? 2. See it's here. So in parallel beta, you can use this one formula, use it on the side on the rough. It's not given in the NCERT for checking. Okay, multiply on top, add on the bottom. Come on, bhai. Let's move on. CBSE 25, 23, 20. CBSE asked this kind of similar question many times. What is the question? The maximum and minimum resistance which can be made using 4 resistors each of 4 ohm. It is asking us that we have 4 resistance. 1, 2, 3, 4. And the value of each one is how much? 4 ohm, 4 ohm, 4 ohm, etc. Okay. It is asking us how will the maximum resistance come. So beta, tell me what should be done for maximum. In what should I connect all 4 of them in series? So it's very easy. 1, 2, 3, 4. How much are they? 4 ohm, 4 ohm, 4 ohm. What will its equivalent be? Beta, 4 plus 4 plus 4 plus 4. How much is it? 4, 4, 8, 4, 12, 4, 16 ohm. And then it is asking us minimum. Minimum will come in what? In parallel. If you want to reduce resistance, connect them in parallel. So all 4 in parallel. 1, 2, 3, 4. And connect all 4 like this. These are in what? They are in parallel. So whatever is asked minimum, connect them in parallel. Now 1 by R equivalent is equals to, tell me, 1 by 4, 1 by 4, 1 by 4, 1 by 4. The answer will come out to be 1. Look, the bottom is 4. Adding 1, 1, 1 is 4. How much? 1 by 1. If you flip this also, it will still come out 1. So the answer for maximum is 16. The answer for minimum is 1 ohm. Okay. Okay. Let's move on. There is one more small important note. If you see the same resistance R in series, like we saw 4 for our here. I am telling you all these small shortcuts, beta. Your calculation will become fast. Suppose you see R in series, you said 3 times, then R equivalent will be 3 times of R. Simple. Why? Because R1 plus R2 plus R3, R 3 multiplied by R. If you see the same resistance in parallel, R in the parallel, the R equivalent will be R divided by 3. It decreases in parallel like. So divide by number of times it appears. It's smaller. If you see the same resistance in parallel, you solve 3 times, then what is R equivalent be? R divided by 3. If you see 4 times, R by 4. If you see 10 times, R by 10. Here also same thing, as many times, see as many times. Look carefully, you did the same thing in the previous question. We said maximum will come in series. How many resistance in series? 4. How many ohm? 4 ohm. So 4 times 4. 4 times 4, 16. In parallel, how many resistance? 4. Connected in what? In parallel. So the R is divided by, are you feeling confused? R divided by 4. It's 4 times. R. So R divided by 4. Here what will it be? R divided by 4. The value of R by chance was 4 only. So 4 divided by 4. What is the answer? 1. So all these, now you will say, can we use the formula in the exam or not? Don't use it. By it's not given. Use it for checking. It's not written in NCERT. How can I say? Come on, let's move on. CBSE 23. It's homework. You will do it yourself. If 4 identical resistors of resistance 8 ohm are first connected in series so as to give an effective resistance Rs, and then connected in parallel so as to give an effective resistance Rp, then the ratio of Rs to Rp, you will do this. First it said Rs, connect all 3 in series. How many? 4. Connect all 4 in series. Then it said Rp. What did it do? Connect all 4 in parallel. Then what did it ask? Rs divided by Rp. How much? 8 at 8. So 8, 8, 8, 8. 4 times, how much is it? 32. 8, 8, 8, 8. 4 times. So divide by 4. How much is it? 2. So what do we have to find? Rs divided by Rp. It will be 32 divided by 2, 16 I think. You can check it. Come on, bhai, let's move on. Now this is a good conceptual question. How would we connect? It comes in the board. How would you connect 3 resistors, each of resistance 4 ohm, so that the combination has a resistance of 6 ohm? It is saying I have 3 resistors. I have 3 resistors. So sir, write that in there. Are not those one, the resistance ones. 4, 4, 4. I have 3 resistance of 4 ohm, 4 ohm, 4 ohm. How would you connect the resistance each of 4 ohm so that I can get an equivalent of how much? 6 ohm of equivalent. Pause and think for a moment. If I connected all 3 of them in series, what equivalent R would I get? 4 plus 4 plus 4, R1 plus R2 plus R3. How much would this come out be? 4, 4, 8, 4, 12. If I connect them in parallel, think. If I connect them in parallel, I have already calculated the series one. If I connected them in parallel, what would R equivalent come? 1 by R1 plus 1 by R2 plus 1 by R3. 3 are in parallel. We can also think of as 4 divided by 3. 4 by 3, how much is it? 1.33. You can do it that way too. 1 by 4, 1 by 4, 1 by 4. LCM is 4, 3 by 4. Then if you flip it, 4 by 3, 1.33. And both ways 6 is not coming. So it will be neither series nor parallel. That means I have to do some mixing by. Some mixing. Neither all three are in series, neither in parallel. Otherwise, it would be answer. Now, what could be the first way of mixing? That I take any two in parallel and one in series. The second way would be that I take two in series and one in parallel with them. These are the different combinations that will form. Let's try this one. Take two in parallel. I took 4. 4 in parallel. Okay. And connected 1 4 in the series with them. Look. 2 parallel and 1 series. This is the only way. Either way do this or this. Whichever ones give the answer. Now let's see. If I do this, 2 in parallel and 1 in series, what will the equivalent of 4 and 4 in parallel be? Since they are equal, it will be half. You do it with the formula in the exam. 1 by r equivalent equals 1 by 4 plus 1 by 4. So 2 by 4, 1 by 2. So r equivalent will be 2. Yes, that's half right. Now look, how much did this come? 2. And how much is the connected in one? Look, 4. Oh, now the answer has come. What will the r equivalent of these two be? Tell me. They are visible in series. R1 plus R2. How much did it come? 6. It matched. So this is it. What will be the answer? That 2 in parallel, 1 in series. And I know your English is very bad. So you should draw this diagram. Suppose the answer still didn't match, then would try this. What was this? Take 2 in series with that 1 in parallel. Suppose it didn't match. Different combination. Then we would try this. What is this? 2 in series, 1, 2 in series and 1 in parallel with them. This would be 4 and 4, 8, 8 and 4 parallel. So 8 multiplied by 4, 32, 12. So this would be 16 divided by 6, which means whatever it would be, some other answer would come from there. If it didn't match, we could do that. Come on, let's move on. CBSE 24, 2016. Again, look, similar question. Show how would you connect 3 resistors, each of resistance 6 ohm. I have one of 6 ohm, another one is also 6 ohm, and the third one is 6 ohm. To get an equivalent resistance of 9 ohm, we need the equivalent to be how much? 9 ohm. If you add 6 in series, look, if I try series, I know the equivalent of 6 in series will come out to be added up, so 18. If I try parallel, it won't be either. 1 by 6, 1 by 6, 1 by 6, 3 by 6, 1 by 2. So answer will come out, 2 ohm will come. So both are not possible. So now I have two possibilities. We'll do that, some mixing. And when we do mixing, either we will do 2 parallel, 1 series. And if this is not successful, then 2 series, 1 parallel. This one is getting solved with this only. Sir, how do you know? You can tell by looking at. Look, your hand also start moving. 6, 6, 6. That's it. Now look, 6 and 6 is parallel. How much is it? It will be half 3. 3 and 6, how much is it? 9. The answer has come. You will do it yourself. Homework. Comment if you do it yourself. So 2 parallel, 1 series. You will write this 2 parallel. 6, 6 in parallel. Half is 3. 3 and 6, 9. Here, let's go. How many times I have to tell you these questions come a lot. But think for a moment, maybe it gives an answer that comes from this one. So try this one too. If it doesn't match, don't give up and think, this can't be done. It can be done. 6, 6, 6. Do it like this. So 6, 6, 12 and 6 parallel and comes to be 4. Suppose it had written 4 ohm. Then you would try this. Yes, your mind should work. Look, you will add 6 and 6, 12. 12 and 6, when you solve in parallel, you will always get 4. 4 will 6. 12 into 6, 12 upon 6. So how much it will be? 12 into 6 by 12 plus 6 is 18. 6 3 is 18. Yes, coming 4. Anyways, this one got solved with 2 parallel, 1 series. If it doesn't work, you will have to try the 2 series and 1 parallel. That you will have to try too. Okay, let's go. CBSE 2020, now by 1 homework, same thing. 3 2 ohm resistance. Come on, comment this one. Now say this one is solved with 2 parallel, 2 series. Comment its answer. Come on, let's move. Now CBSE term 21-22 ask a question that VI graph is given. It asks which one there is correct. Let's assume this A, let's assume this B. Which graph is correct? Which is correct from this? Now I tell you one thing here. RS is representing the series combination and my RP is representing the parallel combination. It asks which one will be correct. Pause and comment, then you will see which one will be correct. It should be done. By we know one thing, the equivalent resistance of series always comes out to be more than parallel. By parallel is minimum, series is what? Maximum. So the resistance of series will be more. If I recall the VI graph, this is VI graph. What did its slope give? Resistance. Now the more its slope is, the more resistance will be. So whose slope is more here? The series ones is more and the parallel ones is less. That's also correct because the series resistance should be more as compared to parallel. So this looks correct. Look here, whose slope is more here? The parallel one slope. This angle is made more and series is less. So according to this, the parallel resistance is more than series, which is wrong. So this is wrong and this is correct. Is it clear, bhai? Come on. Now look at the device in our homes, like our television, our AC. Sir, I don't have AC at home. There is cooler, a heater. How should we connect all these at home? Should we connect them in series or connect them in parallel? So remember, beta, we connect all the gadgets at home in parallel. Why do we do it? The board exams ask the question. So the advantage of parallel over series combination. What is the advantage of connecting in parallel? First one, independence of appliance. Every single appliance is independent in itself. Let's understand. Suppose I have a TV, I have a cooler, I have a fan at home. Let's assume all three are connected in series. Now you messed with the remote at night, bhai. You are watching something inappropriate on TV. You messed with it. And what happened? The TV broke down. Now if the TV broke down, the current passes like this in series. Now it won't pass through the TV at all. Papa came, bhai, Papa switched on the cooler. The cooler is also not working because the current didn't pass through the TV. It didn't reach cooler. Now Papa is hitting with a belt. You could fall nothing. So bhai, the devices ahead will stop working if one device is false. But it's not like in the parallel. Here's the TV, here's the cooler, here's the fan. The current come from here. The TV's current went separately, the coolers went separately, the fans went separately. Even if the TV breaks down, Papa cooler will run just fine. So what is it? Every appliance is independent in itself. The failure of one doesn't affect the other. This is what is written here in English. If one appliance fails or there is a short circuit in one branch of the circuit, the other appliance continue to operate normally. This is the first point. What is the second point? Every device is the house which needs different current. By like AC, cooler, heater, these need more current. 15 ampere of current. TV runs on 5 ampere. Fan runs on less current. So every device needs its own different current. Is this thing possible in series? No, it is absolutely not possible in series. By what happens in series? The same current will flow. Suppose 15 ampere of current was sent from here, so that cooler would run. That it will blow up. Blow up means table will gone. It won't handle this much current at all. You absolutely can give different current to every device in series. You can give it in parallel by. In parallel, we said by 5 ampere to the TV, give 15 ampere to cooler, give 4 ampere to the fan. It said, okay, we will give whatever you ask for. We give different device, different current. So devices of different types need different current. This is the second problem that is solved in parallel. This couldn't happen in series. We couldn't give different current to the different devices. The third point is, tell me in which one is the equivalent resistance less? In parallel. So the overall resistance decreases in parallel. When the overall resistance is less, beta, the utilization of energy is very excellent. It's very efficient. So reduced equivalent resistance. By what happens in parallel? The resistance become minimum and maximum in series. That's why we do in parallel, so that we get reduced equivalent resistance. Along with that, remember one line, more efficient energy consumption. If the overall resistance has decreased, then there will be more efficient energy consumption. So you have to remember these 3 points about the advantage of parallel over series, or why we connect in parallel at home. What is the first one? Every appliance is independent. What is the second one? Different devices need different kinds of current. And what is the third one? Reduced equivalent resistance. Look, the same question is asked repeatedly in 24, 20. What is it? That should we connect in series or parallel? The electrical gadgets in your house. Electrical gadgets in your house in series or parallel? In parallel. List 3 reasons for your answer. Here are the 3 reasons. Come on. Now we will study beta electrical circuit. This is where you face the most difficulty. Calculating current in different resistance, finding the ammeters reading, potential difference, which I will explain very well. The first thing is, what is a circuit? Beta, any closed path through which current flows. What kind of path? Closed path through which the current flows. We call it circuit. Continuous and closed path of electric current. It should be continuous and closed. Now circuit has some components or elements. Let's review quickly them. First, the electric cell. Everyone knows a long line and short line. Then what do we have? A battery. What is this? Combination of cells. Small line, big line, small line, big line. This is connected like this. Third is plug key or switch. Look, I have told you this is a plug key. If the dot is out, what is it? It's off. Current won't flow. If the dot is plugged in, it's on and current will flow. What else is there? Wire and join. If few wires are joined among themselves, then this one wire, they are joined together. Next is wire crossing without joining. Suppose one wire is like this, and without touching, we have to pass this wire. Just bring it like this and make it like this, meaning it pass without touching this. Crossing without joining. Okay. Next, look at electric bulb. So beta, either make a bulb or for make something like this, like a heart. This is the symbol of bulb. The resistance R, everyone knows, we make it jaw. Then variable resistance or rheostat. We don't even see a single question in the syllabus, but it's symbol you should remember. What is a variable resistance? Make resistance like this and then draw an across like this, or make resistance like this and then put an arrow from above. Now what is this? Its resistance can vary. This used in labs and all. If you want to do an experiment, want to prove something, then we need such a resistance whose value we can keep changing. Where will we keep bringing new resistance? So just one resistance is there. When we say give 10 ohm, it give 10 ohm. When it says 5 ohm, so 5 ohm. This is called variable resistance. Make a resistance and draw a line across it, or make a resistance and put a line dropping across it. Next is ammeter. Inside a circle A is written. Voltmeter is inside a circle B is written. See, the same question came in CBSE 2025 board this year, that identify this and tell their function. So that is why ammeter. What is its function? To measure electric current. What is this? R, variable resistance or rheostat. Its job to give variable resistance, different resistance. Clear? Okay. Now we will solve circuit questions. Before that, one question I will clear that whole circuit for you. Any kid who has problem in electric circuit, I guarantee after this one question, any circuit question in the world, you will able to solve. Watch every step slowly and carefully. After this, no circuit question will trap you. Let's start. This is a circuit by, what is there? A battery is placed. Mother is this. What does Mata give? Potential difference. It gives whole circuit. What is this? Ammeter is placed. It will read current. One resistance of 4 ohm is there. Two resistance are connected like this in parallel. First thing we have to find equivalent resistance. Okay, bye. Let's assume from the cell here some current comes out. Current always comes out from the positive terminal of the cell. Always from positive. This current came, went here, went into 4 ohm. Then what happened here? The current got divided into these two. Then here again it got joined and went back to the negative terminal of the cell. It came back. Okay. Now if I look carefully, these two are clearly in parallel. They are clearly and seen in parallel. So first I will solve this. So 6, 3. I clearly see they are in parallel. When 6 and 3 are in parallel, equivalent comes out as 2. If you want, calculate. 1 by R equivalent is equals to 1 by R1 plus 1 by R2. LCM will be 6. So 1, 3 2s are 6. So how much is it? 1 by 2. So R equivalent of mine, how much it will be? 2 ohm. Can I remove these two and put the resistance of 2 ohm? Equivalent of these two is 2 ohm. Can I replace them with 2 ohm? Of course, sir, you can. So see this, I did this. I replaced them with 1 2 ohm resistance here. Okay. Remove these two 2 ohms resistance. Now find the equivalent resistance. Now the current beta that goes in this will be the same that goes in this. These two are in series. So their R equivalent will be R1 plus R2. How much? 6 ohm. That means the equivalent of these two came as 2. Then these two in series 4 and 2, 6. So what is this? The equivalent resistance of the whole cell. So my first part is solved. The total equivalent resistance of the whole circuit is 6 ohm. Okay, sort. The next is at reading of ammeter. Now we have to see where the ammeter is placed. Depending on that, the reading will come. Ammeter beta gives current. If I look carefully, the current that came out of the cell is the same that passed through the ammeter. Where is the ammeter placed? We have to see that. With the cell. So the current that came out of the cell, the same that passed through the ammeter. So what does ammeter measure? Current. So I have to find the current that is coming out of the cell. Now I will only talk about the cell. Only cell. So call it cell, call it battery, only this. If I only talk about the cell, then potential difference of cell is how much? 12 volt. Okay. I have to find how much current came out of the cell. The current that comes out of here is the one that will pass in ammeter. Now listen to one thing. What resistance does the cell see? Cell doesn't see 4 ohm, doesn't see 6 ohm, doesn't 3 ohm. Cell is mother beta. At home when mother makes parathas, she doesn't see that Pinto will eat 2 parathas, Chintu will eat 6 parathas, and Pintu's papa will eat 3 parathas. Nothing like that. She just makes 10 parathas and say distribute among yourself. And in the end, no paratha is left for the mother. Then she eats the stale food from the morning. Mother sacrifice beta is very difficult. Cell is also mother. It will say, bhai, tell me total how many people are in the house. So cell doesn't care about each resistance. It will ask, what is the total equivalent resistance of the whole circuit? We said 6 ohm. Cell said, okay, I will give current according to that. You are distribute among yourselves. Now see, V is known, R is known, I has to be found. Apply the viral equation. V is equals to I into R. V is how much? 12. I don't know. R is 6. So a value comes out as 2. Exactly. 2 ampere. Pay attention. This current, don't say it belongs to the resistance or that. Whose is it? Is it of the cell? So how much current came out of the cell? 2 ampere. And that same 2 ampere passed through the ammeter. So the reading of ammeter, I also got the second part answer. Reading of ammeter is 2 ampere. Okay. Let's move to the next part. Understood till here. First find equivalent resistance of whole circuit. Then apply this equation for the cell. For each component, equation will be separate. For the cell, we applied potential difference of cell is 12. Resistance shows to the cell is whole circuit is 6. V is equals to IR. From here, I is 2. Next is potential difference in all resistors. Current in all resistors. Once you practice this, nothing is left in the circuit. What else it will ask? What is potential difference in all resistance? What is current in all resistors? Okay. Listen carefully. This 2 ampere current that came out from positive of the cell went. Well, this 2 ampere current go into 4 ohm. Of course it will. Yes or no? This same 2 ampere went into 4 ampere. So in 4 ampere current is how much? 2 ampere. This same 2 ampere continued and came here. And how it is passed? With the 2 ohm it passed. But if I see from here, then this is 2 ampere came out of cell. Through ammeter also 2 ampere. Went and this also 2 ampere. But here the current will get divided. How much it will be? 1 ampere it will be. Not like this beta. Not always equally. One resistance bigger, one smaller. You will not decide. So in this one current is definitely 2 ampere. These two we had to check. So my 4 ohm game is very simple. In 4 ohm current is 2 ampere. So let's solve the 4 ohm first. Current is 2 ampere came out and went to 4 ohm. So if I see the story of 4 ohm first I see the story of 4 ohm resistor. So resistance of 4 ohm resistor is 4 ohm. Current also I got into this how much? 2 ampere. Now we have to calculate V. Now we have to calculate V in this resistance. So V is equals to IR, on which is this apply in the 4 ohm. Here V, it will come from whom? 4 ohm. How much is the current? 2. How much is R? 4. So how much it become? 8 volt. Now this 8 volt is the potential difference of whom? Of this resistor. How much is here? 8 volt. So this resistance is solved. How much is the current? 2 ampere. Potential difference? 8 volt. Now it is about these two, that how much current will pass through it and how much is the potential difference. How we will solve this? Listen carefully. Listen carefully. I want potential difference across this, and this also. If I beta call this point X and I call this point Y, so 6 ohm is connected to which 2 points? With X and Y. To which is the 3 ohm connected? X and Y. So the potential difference between X and Y is, what is the potential difference? It is between 2 points. So whatever is the potential difference there between X and Y, the same will be for 6 ohm and same for the 3 ohm. The potential difference is the same as parallel. Why? Because both are connected to the same points. Between X and Y potential difference, that is same for 6 ohm and 3 ohm. Now how to calculate the potential difference between X and Y? Alright, can I remove 6 and 3? Can I remove 6 and 3 and replace with its equivalent? Look, this is 4 ohm. And after removing 6 and 3, this is our resistance of 4 ohm. And what was the equivalent of 6 and 3? It was 2 ohm. Can I remove 6 and 3 and put 2 ohm here? Absolutely right. Will this 2 ohm resistance also be in between X and Y? Absolutely. I removed this. And what did I put here? Resistance of 2 ohm. Now look, how much current came here? 2 ampere. This same 2 ampere current went where? Went to this, into 2 ohm. Current will go differently in these, but into their equivalent, into their total resistance, same current will go, the 2 ampere one which is coming. So if you calculate potential difference in this resistor, in this resistor, so what is the resistance? 2 ohm. How much current did pass? 2 amperes. What will be the potential difference? V is equals to IR. How much is its I? 2. How much is the R? 2. How much? 4 volts. So the potential difference is 4 volts. In which one? Into their equivalents. Here comes 4 volt in their equivalent. But beta, this potential difference is between X and Y. What is the potential difference between X and Y? 4 volt. To which is the 6 ohm connected? To X and Y. So here the potential difference will be 4 volt. And 3 ohm is also connected to which point? To X and Y. Here also potential difference 4 ohm. See, this is over. Array, sir, what have you done? Same in both. Yes, it happens to same. Okay, sir, how did you calculate? Very simple. I don't know how to calculate the potential difference for each one because I don't know the current. The current was changing here. Here it is some I, some other I. So how do I calculate V? V is equals to IR. So I did one thing here. I got the equivalent this. I saw how much current is going through the equivalent. The 2 amperes that were coming, that passed through the equivalent. I said, let's see the story of equivalent. Resistance is 2 ohm. 2 ampere current is passing through it. V is equals to IR. 2 2s are 4. In parallel combination, beta, the potential difference that will be their equivalent. The potential difference will be the same for each one. Do remember this. In parallel combination, whatever be the potential difference of their equivalent for the same potential difference will be there for each one. Okay, we got the potential difference. Now current is this and current in this left. It is very easy, beta. Two things are known. The third thing we have to be calculate. Deal with it separately. I took 6 ohm resistor. How much is R? 6. Current, I don't know. V, I know. How much is V? 4 volts. Apply the equation. V is equals to I into R. V is 4. I is a not known. How much is R? 6. From here, I will become 4 upon 6. Divide it. How much comes? 2 upon 3. So, beta, how much current is passing? 2 upon 3 amperes. 0.66. It came in fraction. What can I do? All right. Second, see the 3 ohm resistance. Look at the 3 ohm resistor. How much is R? 3 ohm. How much is current? I don't know, sir. How much is V? 4 volts. It must be the same potential difference between the two. I applied V equals to IR. 4 is equals to I into 3. From here, 4 upon 3 becomes the value of I. So how much current is passing here? 4 upon 3 ampere. Now, if you don't trust it, then come here for once. Let's check. Come, let's check. How much current was coming here? 2 ampere. What did it become after dividing 2 upon 3? 4 upon 3. If 2 upon 3 and 4 upon 3, I did addition, then what happens? LCM is 6. How much is 2 and 4? Sorry, LCM is 3. LCM is 3. 2 and 4 is 6. How much did it come? 2 ampere. Oh. Means this very 2 ampere current divided into what? 2 upon 3, 4 upon 3. If you take it back here and add, how much current will be seen? When I did these, how much current did it become? 2 ampere. The current you took from the cell, the same amount of current will have to return. If you took a loan, then you have to repay. All the current we took from the cell, return to it. So we checked everything is right. 2 amperes are divided into 2 upon 3, 4 upon 3. Added it, again 2 amperes. Now there comes one confusion. Total cell potential, everything is solved, and this resistor current and potential difference, and this resistor current and potential difference, and this resistor current potential difference. Parallel was confusing a bit. What to do? Calculate its equivalent. The same 2 ampere current will pass through equivalent. Here calculate their potential difference. V is equals to IR. Whatever the potential difference in this, the same potential difference will be in the each one because they are in the between same point. All right. One thing may be confusing if I make you think. Here it is 12 volt, 8 volt, 4 volt. So 8, 4, 12, 4, 16 volts. Wrong. What is happening? It is wrong. It comes more if you add the potential difference. No, beta, it is not like this. The parallel is considered one system. Equivalent. If you add this, then there is one system. Here it is. The potential difference is 4 volt. The potential difference 8 volt. Add 8 and 4. How much is it? 12. So don't make the mistake of adding parallel separately. It's over, beta. All the questions from the circuit are over. Come, let's do it. CBSE 2025. One circuit is given to us. Calculate the value of following. First, total resistance of the circuit. This is the circuit we have. This is our mother cell. Some current will come from here, went into this, it will divide, current moves forward, then went here, then divide, then again return to the cell. The question that I did, you will not find any better question. Let's go by. Now what do you have to calculate first? Total resistance. It's clearly showing how are these two in parallel. These two, how is it looking? In parallel. So 10, 15, and which they will form? And the parallel. If it's in parallel, so 1 by R equivalent is equals to 1 by 10 plus 1 by 15. LCM is how much? 30. 10 3 is 30, 15 2 is 30, 5 by 30. Tell me how much is that? 1 by 6. So their R equivalent came out to be 6 ohm. Removing both of these, I can consider it 6 ohm. Similarly, both of these in parallel, 6 and 4, meaning 60, 40. These are also in what? Parallel. 60, 40 is also in parallel. So 1 by R equivalent, 1 by 60 plus 1 by 40. How much will be LCM of 60 and 40? 120. So 60 2s 120, 43. So 5 upon 120. How much it will be? 5 1s are 5, 5 2s are 10, 20, 1 by 24. So our equivalent become 24 ohm. Meaning the equivalent of both of these is 24 ohm. Now think carefully. What was the equivalent of these? 6. What is theirs? 24. What are the 6 and 24 in series? If you wish, I can make it and show. I'll make it here. Suppose there is our cell. Okay. By removing these two, what can I put? 6 ohm, right? And here it's the meter and all there. And by removing, then I can, what can I put by removing 60 and 40? 24 ohm. And this went and connected with the cell. Now they might seem to be parallel to you. But concept master has taught you. Current got released from here, and the current that went here, did the same current go here? Where is the current same? In the series. Means 6 and 24 are same in what? In the series. Tell me it's understood or not. Did you get it? I did a very simple thing. I made the circuit again. I made the circuit again according to the equivalent resistance. So I told you, by removing these two, 10 and 15, I can put 6. So I made a cell here. By removing these two, what did I put here? 6. We move no from here, their ammeter and all. And here too, by removing both of these, removing 60 and 40, I can put 24. Now by looking, what might they look to you? In parallel, but they are beta actually in series. Think, the current that would start from here, which would go in this, the same current moving, would go in this. Both have the same current. So 6 and 14 are not in parallel. By making them above and below, it doesn't become parallel. Current in both same. See, it's one after other in series. So beta, what are 6 and 24 in? In a series. Now R equivalent of whole circuit, of whole of the circuit, how much it is? R1 plus R2. So 6 and 24, how much it become? 30. So my first part is solved. The total resistance of the circuit, how much is it coming for me? 30 ohm. What's next? Total current drawn from the source. Beta, what is source? Cell, which is source, which are giving the potential difference here. Now he is saying how much current would be drawn from the cell. I have told you, what does the cell see? It sees each resistance? No, total resistance. If I talk about the cell, here is the cell. What is the potential difference of the cell? It's here. How much is it? 15 volt. Which resistance would the cell see? The cell will see whole circuit resistance, not each resistance. How much is the resistance of whole of my circuit? 30 ohm. Cell saw the total resistance of 30. It asked, what is the equivalent of both of you? They said 10 and 15. What do we get? 6. They said, what's their equivalent? 24. The cell said total 6 and 24, 30. We have to calculate current. V is equals to IR. For whom? For the cell. V is 15. I don't know. R I have kept 30. I would be 15 by 30. So how much it become? 1 by 2. This is 0.5 ampere. So how much current is flowing out of the cell? Here is the cell. How much current is flowing out? 0.5 ampere. So I have got the second answer to current drawn from source. How much current is flowing from the cell? How much current is flowing from the cell? 0.5 ampere. Next, potential difference across the parallel combination of 10 ohm and 15 ohm resistors. They are saying that how much would the potential difference between them? As much as in this, so would be in this. And the same would be there in the equivalents. It is become very easy. That is what is saying, potential difference across the parallel combination of 10 and 15. So beta, what's in this, same will be in this, potential difference would be same, and the same would be in there, equivalent. So it's a halva question by. See, how much current came out of cell? 0.5 ampere, right? The same 0.5 ampere gone, the same 0.5 ampere would divide, but it's not asked from you. You are asked what's the potential difference across them. There would be same potential difference across them, which would be there in equivalent. So if I remove 10 and 15 and make their equivalent, how much is it? 6. That was their equivalent, 6. So whatever potential difference would be in their equivalent, the same would be in there, and the same is there. Now see, from the cell 0.5 ampere came, it would divide in this, but in their equivalents at the same 0.5 will go, na? See how much current is going from here, 0.5 ampere. It would come and divide here. But if we make an equivalent of them, then how much current is going them? 0.5. So 0.5 came, some would go here, some would go here. But if I remove those two, and what I put here, a 6 ohm resistor I put here, 6 ohm, then whole of 0.5 will go into it. Now for the resistance, it's very simple. R value is 6 ohm, current value is 0.5, V value, V is equal to IR, I is 0.5, R is 6, so 6 into half, how much would it be? 3 volt. So beta, their equivalent has a potential difference of 3 volt. So in each one the potential would be 3 volt and 3 volt will be there. Game over. Say, has it come? So potential difference across the parallel combination of 10 and 15 ohm resistor is how much? 3 watt. Ajay, now suppose they ask potential difference in this across 60 and 40. Would have done it. Simple. What is equivalent of 60 and 40? 24. So 24 into 0.5, 12. It's even simpler. See how much is gone here? 3. How much was in cell 15? This took 3. So how much was F12? So 12. Didn't get it. How much did this one take? 3 and 3. How much would take this? 12 and 12. So 12 and 3, 15. And don't add twice. No, because in the equivalent 12, in their equivalent 3, 3 and 12, 15. Clear? What I have taught you, no better question would be found by. I have made you practice. Now see the 1-bit diagram. CBSE 24. Draw a schematic diagram of a circuit consisting of a battery of 4 1.5 cells. 4 cells, each of 1.5 volt. I have taught you many times how to make a 5 ohm resistor, a 10 ohm resistor and 15 ohm resistor and a plug key all connected in series. So first all by in this, you will have to make a diagram. First of all, I need to make 4 cells. 4 1.5 cell. How it would connect? One's big stick, second small stick. First one is big, second small. It's big and it's small. It's big and it's small. 4 cells are made of how many volts? 1.5 volt, 1.5, 1.5. How much would be total? 1.5, 1.5 would be add. Then how much would be? 6 volt. How much net would be give? What's next? A 5 ohm resistor, 10 ohm resistor, 15 ohm resistor and a plug key. So beta, just after the cell, put a plug key. This is a plug key. If dot in the middle, then current, otherwise not. Now let's go. There are 3 resistors. One is 5 ohm, one is 10 ohm, one is 15 ohm. And how are they all connected? Series. So beta, directly we'll keep it. Everything is in series. Add it directly. What do I have? One is 5 ohm. What else do I have? 10 ohm. What else do I have? 15 ohm. Added all of them directly. Circuit complete. This is 5 ohm. This is 10 ohm. And this is 15 ohm. So circuit is made. Now the electric current passing through this circuit. First of all, it's asking. Let's close this. It's on. Now it's asking that how much current would be. Bhai, where would the current flow from? From the cell. So I'll have to see from the perspective of cell. Electric current passing through the circuit. Bhai, from here the current I that flew, that same current I went the first resistance. The same current went to second one. The same went to third. The same I we return to the cell. So in the whole circuit, what is current? Same, because everything in series. So the same current is asked. So if I talk about the cell, then what would be the potential difference of cell? 1.5, 1.5, 1.5. So 1.5 added 4 times. So how much it will be? Potential difference 6. Now how much current flew from the cell? We have to find that. How much current? How do we find the current from the cell? We'll put V is equal to IR. How much resistance will the cell see? Will the cell see 5 ohm, 10 ohm, 15 ohm? No. The cell adding everything. So the cell would see beta equivalent resistance. How much equivalent resistance be? It's very simple. What all three seen? They are clearly seen in series. So R equivalent R1 plus R2 plus R3. So 15, 15. How much has it become? It's 30 ohm. So how much resistance is seen in the cell? 30 ohm. Now put the equation of the cell. V is equals to IR. How much is V? 6. How much is I? We don't know. How much is R? 30. So I is equals to 6 by 30. It means 1 by 5 ampere. Or if you want 0.2 ampere. This is the answer. Clear? Second, potential difference across the first part is solved. How much current came out of the cell? 0.2 ampere and 1 by 5 ampere. The second one, potential difference across the 10 ohm resistor when the plug key is closed. When the plug key is closed, close means the dot is here. And what do we need to find the potential difference across 10 ohm? Beta, now it's very simple. Look, how much the current came out of the cell? 0.2. The same current went into the 10 ohm. So for 10 ohm, I have to apply the viral equation. So if I look carefully at 10 ohm, here is 10 ohm. What current is it going through it? Is it the same that came out of the cell or something else? The same that came out of the cell, it is going. How much is it? 0.2. So how much current is going? 0.2. What do we need to find? Potential difference. So the R value become 10 ohm. For what we are applying it? For 10 ohm resistor. Okay. The value of I become 0.2 ampere. V is equals to IR. For what? For 10 ohm. So how much is I? 0.2. R is how much? 10. So how much this will be? 0 gets cut by 0, 2 volt. So potential difference across the 10 ohm resistance is 2 volt. How much will come in this? 0.2 into 5. So this become 1 volt. And this 0.2 into 15. So this become 3 volt. So 3. So 3 to 5, 1, 6. Look here, how much is coming? 6 volt. Clear? Look in this 15 into 0.2 is how much? 3. 5 into 0.2 is how much? 1. And this is how much? 3. 3. Sorry, here 2, 3, 5, 1, 6. Meaning everything is correct. Come on, bhai, let's move on. Our next topic is power. What is power? The rate at which electric energy is flowing is called power. The rate at which electric energy is consumed is called power. Now, what is the formula of power? Whichever element we talk about, listen carefully to me. Whichever element we talk about, whether we talk about resistance or talk about cell, whichever element we talk about, the formula for power will be P is equals to B into I. Power P is equals to B into I. How will you remember it? Power. What will you remember? Power. Have you heard of power? No, you haven't. So power is just like Hawaii, like that power. Power P is equals to B into I. Now suppose I don't know B in the question. I only know I. I don't know B. What should I do? Better for a resistance, we know one thing, that if the current in it is I, the potential difference is V and the resistance is R. So I have a viral equation of V is equals to IR. Suppose I don't know V, then can I substitute IR in place of V? Suppose V is not known in the question. Can I substitute IR in the place of V? Bhai, what is the formula of power? The power formula is V into I. Power, V into I. Very simple. Suppose V is not given in the question. Then I can find V, right? V into IR. So I take this IR and place it here. So I into I square, and R is applied, I square R. Now suppose I don't know I in the question. It's possible that I don't know. No problem. I'll take the value of I from here, V upon R, and paste it here. I don't know I's value, V upon R, paste it. So V square upon R. So these are the three expressions of power. Memorize one. Power P is equals to VI. Power P is equals to VI. Now remove V from this, place IR in place of V, I square R. Once remove I from this, in place of I, place V upon R, V square upon R. Okay. What is the SI unit of power? Watt. Watt लगा डाली. Watt. Capital W हमारी लग गई. Watt. Everyone knows the unit of potential difference volt, the unit of current is ampere, and the unit of resistance is ohm. Look at the question, CBSE 25, 24. Question is coming. Define electric power. Electric power is the rate at which electric energy is consumed. This is energy. How fast it is consumed. Rate at which electric energy is consumed. A small definition is written. Express it in terms of potential difference V and resistance R. You will have to write this one. V square upon R. Is that clear? So if we have remember P is equals to VI. If we remember P is equals to VI, we'll remove V once and put IR. So it becomes I square R. And we'll remove I once and put V by R. V by R. So it becomes V square by R. If you remember this, both will be formed. Come on, bhai. Look at the question, CBSE 2024 question. In the given circuit, calculate the power consumed in watt. Watt is its unit. And the resistor 2 ohm. In this beta, I have to find the power. The value of the element which is talked is to be kept. Last year, students were so confused in this question that what do we keep in power? Apply the formula for the element which is talked about. Let's go. Now we talked about 2 ohm resistor. What do I have to calculate beta? Power. If I see the formula of power, then I must know two things. Power, P-A-V-A-I, power. So the formula for power is P is equals to V into I. Neither I know V in this, nor the I know. If I have known any one, I would have calculated the second one from R or use some other formula, but I don't know anything. Now what will I do? I must calculate current in this. How do we calculate current? We have learned this. We took 6-volt battery. Some current will flow from here. Whatever current will flow will go to this. The same will go to this. I have to calculate current. How will current be calculated? We will have to see cell. If I see the cell, then the potential difference of cell. Beta, don't confuse in this. Why am I looking at cell now? Because this cell looks pretty. You have that condition. Bada samajh aaya tenu, samajh nahi aaya kato kaida hai dil da. Everything is around. Slow down. I said power is to be calculated here. The formula for power is V into I. Neither I know V nor I know I. So I want to calculate I in this. I will be found only if calculate current from the cell. So if I talk about cell, dual cell, how much is V? 6 volt. How much resistance will be the cell C? Cell C is equivalent to the whole circuit. What will be the equivalent of this circuit? What are they both looking in? They are looking in series. So how much will be the equivalent resistance? R1 plus R2. How much? 3 ohm. Both seems to be in series. So how much did the cell see? 3 ohm. Now how much current will flow from the cell? So I will apply V is equals to IR for cell. How much is V? 6. I don't know I. How much is R? 3. So the current flowed from the cell beta 2 ampere. The current flowed from the cell 2 ampere. 2 ampere. Current is flowed. Here is also 2 ampere current went going. It also went here. Look carefully at the 2 ohm resistance. Look carefully at the 2 ohm resistance. How much current is passing through it? 2 ampere. I know R, I know I. What do I know for this resistor? I know R, 2 ohm. I know I. How much is it? 2 ampere. I don't know V. Let's calculate V. V is equals to I, P for this. V inside this, not this, inside this. V is equals to I into R. So 2 into 2. How much is it? 4 volt of potential difference. Now you can calculate the power. Power P is equals to potential difference of this resistor. How much did it come? 4 volt. So V into I. How much is it? 4 into 8. What is unit? Watt. Capital W. 8 watt. Now suppose I don't calculate V. Then also I can calculate power. What is the formula of power? V into I. Can I place IR in the place of V? Absolutely I can. Then what will it be? I square R. What am I talking about? About 2 ohm resistor. Now how much current is there in the resistor? 2 ampere. So square of 2. How much is the resistance? 2 ohm. So 2 2s are 4, 2s are 8. So this way also 8 volt will come. Isn't it? 4 volt is here and here it is 4 volt. 4 and give added 4 and 2. How much will we get? 6 volt. Look what will happen in this. IR 2 ones are 2. Is it clear? Let's go badhiya. What students mistake in this is that they take 6 volt of battery for VI and take current as 2 6 are 12. They say 12 watt is the answer. Are 12 watt is power, is battery generated power. But how much this 4 ohm resistor, how much is the 2 ohm resistor is getting? 8 watt. But students tell the answer for this 12. They say P is equals to V into I. So they do 6 into 2 and say 12. But 12 is supplied by the battery. How much did this get? 8. How much did this get? 4. Now it's understood. Let's go to the next. CBSE term 2, 2020 and 22. An electric heater rated when you get the rating of power. Sometimes we get the rating of power. Power rating tells you two things about any appliance, whether it is bulb, AC, fridge, TV or heater. It tells us two things. One, it tells the power, and other tells the potential. So look here, rated 1100 watt. What is 1100 watts to it? Power. And the potential is given for us, operates at 220 volts. 220 volts. Now what is asked from us? Calculates its resistance. First thing they ask us are, what is second thing they ask us? Current is asked. Beta, it is based on a very simple formula. Apply the formula for power. Power P is equals to V into I. How much is the power? 1100. The value of V is 220. Current, I don't know. 0, 0, 0 will be cut from here. I is equals to 110 upon 22. 11 ones are 11, 10. 11 twos are 22. How much is it? 5. So my current become 5 ampere. What is the second thing? We had find resistance. Now it's simple for resistance, beta. Apply V is equals to IR. I know the V 220. I know the current is 5. Resistance I have to find. From here, how much the R become? 220 by 5. 5 fours are 20. 5 fours are 20. 44 ohm. Clear? Come on, next. CBSE 2025 came this year. What is it? Consider two lamps A and B of rating 50 watt to 20 volt and 25 volt to 20 volt. Find the ratio of the resistance of two lamp RA to RB. Beta, its powering rating has been told to me. Power rating means I will get two things. I will get its power and I will get its voltage. How much is it for the first bulb? The power is 50 watt. The voltage is 220 volt. Its rating has also been told to me. That means I have been told the power and the voltage. Whenever it tells rating, you will find two things, power and voltage. Look, how much is the power told for the second one? The power is 25 watt and the voltage is 220 volt. It is asking me to compare its resistance and its resistance. So one way is that I calculate its resistance and calculate its resistance and then divide and compare. By how will you find resistance? The formula of power is V into I. Now look, I have B, and what do I need to find? I need to find R. No need to find current wherein. Now think like this. Let's find the relation between P, V and R. Because PV is available, and what do I need? I need the R of this one and the R of this one too. So I need such a formula that includes PVR. PVR. What should be removed from this? I should be removed. How I will replace? V is equals to I into R. So what will be value of I? V upon R. So if I put V by R in place of I, what will it become? V square by R. So this is the formula. My R will definitely come out for this. Will it come out or not? Absolutely. Can I create formula of R? R is equals to V square by P. So I can calculate the resistance. Resistance of A. What would it be? V square by P. By what did I do? Don't get too confused. I simply said that I was given power, the voltage, and asked the resistance from me. So I wrote down power and voltage and resistance was asked. Now I need such a relation that connects PVR. P is equals to VI power. Now I said from this here, I need R and I need to remove I. I said V is equals to IR. I is equals to V by R. So I use the V square by R1. I said let's make the formula for resistance because that we have to find resistance. So V square by P. Okay. If I look carefully, what will the resistance of A here? V square by P. What is V here, beta? 220. So square of 220 by how much is P? 50. And if I find the resistance of B in this way, this will also be V square by P. What is V here? Again, square of 220 divided by how much is P? 25. Now it is asked that you find the ratio RA upon RB. So beta, we will simply divide RA by RB. What is the value of RA? 220 square by 50. And what is below? 220 square by 25. Now look, 220 square and 220 square will be cancelled out. 25 will go up, 50 will come down. So 25 by 50. What did this become, beta? 1:2 is the answer. Is it clear? So it was simple math. Come on, let's move forward. CBSE 2023, you have to do this yourself. I'll tell you a little bit. It is homework. Question number 32. Everyone comment the answer to this. Look what it is saying. An electric iron consumes energy at rate of 880 watt when heating at the maximum rate. When it is running at the maximum rate, at what rate is it consuming energy? 880 watts. What means power? So what is its power at the maximum rate? It is 880 watt. And 330 watt when the heating is at the minimum. What is 330 watt to? It is power when the heating is what? Minimum. So the power for minimum is 330 watt. Acha. What is next? If the source voltage is 220 volt, the voltage being received is how much? 220 volt. This time 2, this time 2. The source voltage. What is source beta? The AC source. We get home. What is at home? 220 volt. Calculate the current and resistance in each case. So you have to find the current here. You have to find the resistance here. You have to do the same thing here. Well, do it. Well, put P is equals to VI. I will come out. Then we will use V into IR for R. So comment the current and resistance for both of them in this. Come on, let's move forward. CBSE 2320 was a very tricky question. Don't get too confused. Two LED bulbs of 10 watt and 5 watt. So I have two bulbs, 1 and 2. One is 10 watt and another is 5 watt. Are connected in series. If the current flowing through the 5 watt bulb, how much the current is flowing from this? 0.005 ampere. The current flowing through 10 watt bulb, how much the current flowed from this? Pause and comment. It's totally alva question. What are you calculating by? How is the current in series? Same. They both will have same current, 0.005 ampere. In the series, the current remains the same. So it is a very simple concept question. There is not much of game of power and all. Let's move on. Next is beta electric energy. Now what is electric energy? Electric energy beta in a circuit given by cell. Because of this cell, the electron moves and the current moves. Who is the source of electric current? It's supplied by cell, or it can be generator if there is a generator somewhere. So now what is the formula for electric energy? Power into time. What is the formula? Power into time. What is electrical energy? Electrical energy is kept in a pot. What is the energy kept in beta? What is the energy kept in? Energy where all the power is kept in a pot. Power into time. Now listen carefully. The accepted unit for the electrical energy is kilowatt into R. How would it come? Listen carefully. Power you have to keep in kilowatt. Sir, power is in watt. Suppose the power is given 50 watt. So convert it in kilowatt. How will you do it? Whatever power is given, divided by 1000. Keep the power in watt here. Whatever is given in watt, divided by 1000. What did we get? Power in kilowatt. And time beta we have to keep in R. Okay. Power in kilowatt, time in R. We multiplied it. What happened? Kilowatt into R. The unit of energy is kilowatt hour. This is the unit of electrical energy. The unit of energy or the work unit is joule. We read it. The unit of work is joule. So beta you have to remember the conversion to SI unit of energy is joules. What is the SI unit of energy? It is joule. But for electrical energy, the common term become kilowatt hour. How did it come? What to keep the power in kilowatt. How? By dividing the watt by 1000 and the time in hour. Now you understand this. Suppose my energy is in kilowatt hour and they ask the energy in SI unit. So remember this, 1 kilowatt hour is 3.6 into 10 raised to the power 6 joule. This you should remember. Remember it. 1 kilowatt hour 3.6 into 10 raised to the power 6 joule. Okay. After this, there is one about making the bill, but we'll do it later. Let's do a question first. For a heater rated 4. Now see the rating is given. Let's do a question, then I'll teach you another thing. CBSE term 2, 21, 22. What is it? Rating is given. What is the power of beta? 4 kilowatt. And the voltage is given 220 volt. In rating, we get P and V. Calculate the following. First, energy consumed in 2 hours. So first of all, energy is consumed from us. What is time given? 2 hours. They ask to energy beta. What is the energy kept in? It's kept in a pot. So power N2. We'll put the formula of time beta. So energy is equals to power. What should be the power be in kilowatt? N2 time. What should be the time in hour? Now see, what is the power given to us? 4. What is it in kilowatt? That's correct by. What is my time? 2. What is it in hour? Right. So 4 2s are 8 kilowatt N2 hour. This has come to be energy. Now it asks in joules. So we'll multiply it with what? You will have to memorize. 3.6 into 10 to the power 6 joules. If we multiply with 3.6 into 10 to the power 6 joules, then we will get the energy in joules. Then it's saying cost of the energy consumed. We have to find this. What is this? Better you must have seen it at home. There is an electrical meter at home. It blinks like this. Blink, blink, blink. Does it or not? Have you seen the electric meter at home? Blick, blick. What is it counting? Is it counting the potential difference? Is it counting the current of the house? No. It is concerned with how much total energy are you using. The bill that we get at home is of energy. That how much total energy we did use. Someone is using heater at home for 50 hours and then someone is such that is using fan and cooler altogether. So the electricity department is not concerned with what you are using at home. They are asking how much total energy is used. So the blick, na, that is 1 kilowatt hour, 1 kilowatt hour, 1 kilowatt hour, 1 kilowatt hour. So as times the meter blinked, how much energy went in the house? 1 kilowatt hour, 1 kilowatt hour, 1 kilowatt hour. So we say now, how much units has it done? Don't the fathers count? Arey yaar, lot of units have come this time. This time it happened that it's 200 units. So what's that 200 unit? 500 unit. What is 500 unit? It means 500 kilowatts have been used. Now what happens? How much does a 1 unit cost us? It's 10 rupees. So for 500 units, how much it will be? 500 into 10. Okay. So this is how we make electricity bill. So what does the electric meter measure? 1 unit of energy. Meaning when 1 unit is blinked, how much did it become? 1 kilowatt hour. What will be total bill? Add the number of units. The number of units means energy in kilowatt hour multiplied by price of 1 unit. Bhai, if someone asks me make a bill, so I ask bhai, how much for 1 unit? They said 10 rupees. We ask how many units we are using now? 1, 2, 3. How many kilowatts are? 1 unit means 1 kilowatt hour. So to make the bill, take the number of units into what will you do? Multiply by the price of 1 unit. What is the price of 1 unit? Now what is the number of unit? This is number of kilowatt hour. That means how much energy was used in kilowatt hour. So what is the formula for the bill? That you find the energy and what? In kilowatt hour. However energy is used in kilowatt hour, suppose it's 100 kilowatt. It means 100 units. 1 kilowatt hour, 2 kilowatt hour, we are saying it's a unit. Multiplied by price of 1 unit. Now a question comes on this. If 1 kilowatt hour is priced at rupees 4.5 rupees, then the cost of energy consumed, tell me what the bill is currently in your area. Everyone lives in different city, comment it. So it is asking us if 1 kilowatt hour cost 4.5, then cost of energy. So it is asking bill. So bill is equals to number of units multiplied by the price of 1 unit, right? Now number of unit meaning number of kilowatt hour, meaning put the energy in kilowatt hour. So how much energy is there? 8 multiplied by how much does 1 unit cost? 4.5. 8 5s are 40, 8 4s are 32 and 4 is 36. So a bill of 36 rupees was made sa paid here. Let's move forward. CBSE 2025, 2024, what is it? The rated voltage of an air conditioner is 220 volt. This air conditioner consumes 22 units of electric energy in 10 hours. Calculate power rating of air conditioner. So to us, by what information is given about an air conditioner, we are given the information that how much voltage does it use. It uses 220 volt. This air conditioner consumes 22 units of electrical energy. How much energy is it using? 22 units. 1 unit means 1 kilowatt hour. So I can write that it consumes energy of 22 kilowatt hours. And what else is it telling me? In how much time? In 10 hours. In 10 hours. What is the first thing asked for me? Power rating. What all do we have to tell in power rating? We have to tell both P and V. So beta, how do we find the power rating? Apply the formula of energy. Energy is equals to power into time. How much is our energy? 22 kilowatt hour. I don't know the power. How much is the time? 10 hour. How much power will come from air? 22 divided by 10. How much is that? 2.2. And what will be the unit? Kilowatt. What comes from this formula? Kilowatt. The first come out. Current drawn by the air conditioner. Now look, I is asked, look, you have many values. Finding I is very easy. Should I apply the formula of power? P is equals to V into I. I know the power. How much is it? 2.2. What is V? What is V? What is V? 220. Acha. Now don't make this mistake. The power here, we will put the SI unit here. So power will be 2.2 kilowatt. Remember, what is the voltage? 220 volt. And current we have to find. So we have to convert this kilowatt into watt, meaning multiply by 1000. So 2.2 multiplied by 1000 is equals to 220 volt. Beta, here we put things in SI unit, right? Power in watt, voltage, and V, current in ampere. Okay. So 1 decimal point was removed from here. 1 0 is cut. 1 0 will cut from this. 22 will be cut from 22. My current came out 10 ampere, correct. And what is asked from me? And resistance is asked from me. So apply V is equal to YR. How much is V? 220. What is I? 10. R came out from here. How much? 0 from 0 cut. 22 ohm. Look, I found everything. Clear? Next is the heating effect of current. Now think of one thing. When you put your mobile on charging, what do you want? That it should charge. But when you touch it, it also becomes hot. This is also called heating effect of current. Whenever through any conductor or any electric device, when you pass the current, heat forms in it. This is called the heating effect of current. When electric current passes through one conductor or electric device, the conductor becomes hot after some time and produces heat. This is called the heating effect of current. How much heat is formed? This was found using Joule's law of heating. What does the Joule's law of heating say? Suppose there is a resistor and its resistance is R. Current I is flowing. Until t time, current is flowing. Now for t seconds, the current is flowing. So the heat produced in a pure resistor, Joule's law, heat produced in a pure resistor is directly proportional to the square of current, directly proportional to the resistance, and directly proportional to the time. I put the equals to in it. So H is equals to I square R into T. Okay. Now be careful, current is in ampere, resistance is in ohm, and T is in SI unit, seconds. Heat beta, it's kind of energy. So we measure heat in joules. What is the energy measured in? SI unit joules. So if they ask Joule's law of heating in the exam, then what? H is proportional to I square, H is proportional to R, H is proportional to T, H is equals to I square RT. CBSE 23-24. What is the heating effect of electric current? We will explain hereby. Find an expression for the amount of heat produced when a current passes through a resistor for some time. So you have to make the expression H is equals to I square R. Look at the question from 24, 22, 21. What is it? A similar question comes up. There is 5 ohm resistor. How much is the resistor? 5 ohm. Is connected across a battery of 6 volts. How much is the potential? 6 volt. Calculate the energy that dissipates as heat. So we have to calculate heat in 10 seconds. Time is given 10 seconds. So beta, we have the formula for 8. H is equals to I square R into T. Now the problem is that I don't have I here. No problem. This resistor, how much is it? How much? It is 5 ohm. And how much potential is there? 6 volt. I will calculate current by V is equals to IR. So V is 6. I don't know how much is R, 5. So how much is I? 6 upon 5. Take and put it here. So numerator square of 6, denominator square of 5 multiplied by how much is the resistance? 5. How much is the time? 10. Numerator 36, denominator 25 multiply by 5 into 10. Now see, 5 ones are 5, 5 twos are 25, 5 twos are 10. How much are 36 twos? 72. And what is the SI unit of heat? Joules. So 72 joules. So many times I will not be given. Then we will get it. V is equals to IR. Acha. Now what is its practical application? Like when we put our mobile on charge, we don't want our mobile to get it. Like the TV is running on our home. If we keep it running for long, it gets heated. So all the things in which current is passing, all the things existing in this world, if current is passing through it, it will heat. It doesn't happen in semiconductor devices. Now see, they remove the bulb from home and use semiconductor device. It doesn't happen in that. Generally, heat is produced in everything if a current is passing through it. How to take advantage of it? If we take advantage by the press, the iron, its function is what? To get heat. The heater at home, what is its function? To get heat. Kettle, what is its function? To get heat. Oven, what is its function? To get heat. Geyser, what is its function? To get heat. So these are its practical application in which we take advantage of the heating effect of current. In these devices, we put such devices that produces a lot of heat and don't get melted themselves, because what will happen after producing heat? Things get melted. So if you have to make any heating device, what do you have to make? You have to make a heating device like heater, iron, kettle. So to make a heating device better, we use alloys. Why do we use alloys? Their first thing is high resistivity. Resistivity is good. Now look, what is heat produced? What is heat produced? I square R into T. Now as much resistivity, so is the resistance, and as much is the resistance, so is the heat. So that much heat you will get. This is good by that use such alloy which was very high resistivity. So a lot of heat is produced. But at the same time, it must not melt. The heat, it must not melt. So it should also have high melting point. Remember these 2 points. that heating devices which we use at home, it is made of either home or any other heating device. It is made up of alloys which have high resistivity, a lot of heat, but high melting point. CBSE 2025-23, same thing asked how the alloys used. Like there is beta electric bulb at home. Do you know what is the function of electric bulb? It is not to give light, it is to produce it. Its 99% energy is in the form of heat. Because what is the electric bulb made of? Its wire, the filament that is inside is made of tungsten. What is the property of tungsten? It is that if tungsten is heated, it starts emitting light. Acha, why is only tungsten used? This asked in exams. So why we use tungsten in the bulb? Because tungsten has high melting point. It will not melt. Tungsten has a very high melting point. Okay? That was all in it. Let's move forward. Now one more thing is used at home, fuse. You have must heard of fuse was blown. The fuse has blown. What is the function of fuse? The fuse function is to blow. The fuse job is to sacrifice itself to save the other device. Suppose there is an appliance in your house. Let's assume it's a TV. And we said 5 ampere of current should go to the TV. How much should go? 5 ampere current should go. Suppose there was some fault in the electricity department outside the house of pole, etc. And somehow 7 ampere of current came from here. Now this TV won't able to enter 7 ampere of current. If this 7 ampere of current goes into the TV will blow. It will damage. That is why before TV in series, therefore the TV in series, what do we put? We put a fuse wire in a series before the TV, before every device. In all the expensive device, we put a fuse. What does this fuse do? It cuts the current. It says 4 ampere current, go ahead. 5 ampere current, go ahead. 5.2 is fine, 5.3 is fine, 5.5 okay, 5.6 not now, TV will blow. So at a particular current, the fuse melts itself. Itself we will flow ahead. What is the function of fuse? To blow. Now how does the fuse blow? Think. Through the heating effect of current. The wire we use inside the fuse also has very high resistivity. High resistivity means high resistance, and high resistance means a lot of heat. So beta when heat is produced, they melts away. So the fuse wire will have high resistivity, but low melting point. The fuse job is to blow, not to stop. It's not like the fuse didn't melt at all. Heat is being produced, 10 ampere, go by, go blow the TV. No, right, the fuse job is to blow. So beta the electric fuse is a safety device. It is based on the heating effects of current. What really happens beta? An electric fuse is used to prevent short circuits. Fuse has, pay attention, what? Low melting point. It should have low melting point. It shouldn't blow, sorry. It has to blow. So its melting point is low, so it melts. So when high current passes through it, it melts due to heat produced given by Joule's law. By how much heat will be produced? I square RT. So when current greater than a particular current passed, the current became high. More heat was formed. If more heat was formed, it has to melt. So it should have low melting point and stop the flow of current. On what is the electric fuse based? It is based on heating effect of current and Joule's law. H is equals to I square RT. What is the fuse wire made of? Alloy of aluminum, copper, lead, iron. What property should they have? First, produce lots of heat. Lots of heat means high resistivity. Second, melting, meaning low melting point. High resistivity and low melting point. Rating of fuse wire. Rating of fuse wire means how much maximum current I will allow to pass. For example, what should the rating of this fuse wire? Around 5.5 ampere. I won't allow more than 5.5 to pass. So rating of fuse wire means maximum current it can pass. Like the rating of fuse wire can be 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere, anything. Whatever maximum current it allows to pass. For example, suppose I put a fuse before the AC. Now the air conditioner can draw up to 15 ampere of current. So what will be the rating of the fuse wire? 15.5 ampere, 16 ampere. That's it. Don't give current above this. Otherwise AC will be damaged. So the rating of the fuse of different appliances is different. Look, there is a question from CBSE 24. Explain Joule's law of heating. How is the useful in making safety device? So tell them the electric fuse is based on this Joule's law of heating. Acha. Now suppose a question came that here I have a fuse, here I have an appliance whose power rating is given to me, power and voltage. We are asked what the current rating of fuse wire will be. What should be the rating of this fuse wire? 4.5 ampere, 6 ampere on this. Acha. The rating of the fuse wire should be as much as current as this one can draw. So I will have to find the current. Its power rating is given to me. Post, write, comment, you can do it. How much will its current be? Power. Power P is equals to V into I. What is the power? 1100. What is V? 220 into I. From here the 0 will cancel from 0. I is equals to 110 by 22. How much? 11 to the 22. How much? 5 ampere. Means this device can draw 5 ampere of current. So the rating of the fuse wire is 4.5. No, bye. Then it won't run at all. It needs 5 ampere. So this is wrong. 6 ampere seems correct. 5.2. Yes, this is the best. The value that is just above the current the device runs on, strike that one in the options. Mark that, not the rest. Now suppose this option wasn't here. If it was 6, 6.5 or 7, put strike 6. Whatever is just above in the options will be its fuse rating. Come on beta, this chapter is finished. Now there are some definitions. SI unit of so many things. We'll define that. Define SI unit of current, 1 ampere. It's very simple. By what was formula for current? It was QIT. From here we will put I is equals to QIT. I will teach you such a method you will able to define the SI unit of anything. It even comes in the board. So QIT, I is equals to Q by T. I need to define the SI unit of current, 1 ampere. Beta, how much current do I need here? I need 1 ampere. How can I get one? If I put the value of Q as 1 coulomb and the value of time is 1 second, then will 1 by 1 become 1? Yes, it will come. Finished. It is defined. If 1 coulomb of charge flows in 1 second, then how much will the current be? 1 ampere. This is the definition. Look. If 1 coulomb of charge flows through a conductor in 1 second, the current flowing through the conductor is known as 1 ampere. It is defined. Simple. You have to define the current 1 ampere. So current I is equals to Q by T. How much do I need to get this to? 1 ampere. How will it come? If I put this 1 and this is 1. If 1 coulomb charge flows in 1 second, then the current is 1. Define SI unit of potential difference, 1 volt. The formula for potential difference is W by Q. How much of do I need? 1 volt. So how much work done should I put? 1 joule. And how much charge should I put? 1 coulomb. If 1 coulomb charge to move it have to do 1 joule of work between 2 points, then the potential difference between the point is 1 volt. The potential difference between 2 points is 1 volt. If 1 joule of work is done and moving a positive charge of 1 coulomb from one point to the other, this is one method. Otherwise, you can memorize it. Define SI unit of resistance, 1 ohm. Now, what is the formula of resistance? Viral V is equals to IR. From here, the formula of R is V by I. How much R do I need? 1 ohm. That means what should I put this? 1 volt. What should I put? 1 ampere. If on applying a potential difference of 1 volt, 1 ampere current flows through a conductor, then the resistance of the conductor is 1 ohm. Okay. Define SI unit of power of 1 volt. The formula of power is power. How much power do I need? 1 watt. So what should I put the voltage as? 1 volt. How much the current? 1 ampere. 1 into 1 would come. So if on applying a potential difference of 1 volt, the current flowing through a conductor is 1 ampere, then the power is known as 1 watt. That's how you can define it. Here this lecture is over. If you understood, write it in the comments. In the end, I will win. Keep studying. All the very best.